Hello, and welcome to Sleep Gravity. Thank you for being here, in a quiet part of the day, to join us on a journey that will take us very far away, though there is no need to hurry. In this video, we will leave Earth through the power of imagination, travel across the vast reaches of the solar system, and slowly make our way toward the largest planet orbiting the Sun, Jupiter. Perhaps you have seen Jupiter in the night sky before. To the naked eye, it appears as little more than a steady, silent point of light among the stars. But if we could travel closer, if a spacecraft carried us safely through the space surrounding that distant world, the view before us would become entirely different. That tiny point of light would gradually grow into an enormous sphere, wrapped in long bands of swirling clouds, with storms larger than Earth, moons moving quietly through the darkness, faint rings made of dust, and auroras glowing within a magnetic field almost too powerful to imagine. But this journey is not a loud science fiction adventure. We will not fly through Jupiter as though it were an ordinary cloud, because Jupiter is not a world with solid ground where we could land. It is a gas giant, deep, massive, powerful, and mysterious. The closer we move toward it, the more we begin to understand that its beauty lies not only in the colors visible from the outside, but also in the quiet forces at work within and around it. Its atmosphere, gravity, storms, magnetic field, radiation, and the motion of the moons that travel beside it. So allow your body to relax a little. Let your breathing grow slower. You do not need to remember every number, and you do not need to understand everything all at once. Simply imagine yourself sitting beside the window of a quiet spacecraft, watching Earth slowly grow smaller behind you, while far ahead, a distant point of light waits to be seen more closely. Tonight, on the Sleepy Universe, we will explore one simple question. If you were to fly past Jupiter, what would you see? Imagine that you are sitting inside a very quiet spacecraft cabin. There is no loud noise, no sense of chaos like the tension-filled scenes in space movies. There is only the gentle glow of the control panel, the low hum of machinery somewhere behind you, and a wide window opening onto the darkness ahead. Below, Earth is still visible as a blue and white sphere, with clouds, oceans, and small clusters of city lights scattered across its night side. From this distance, everything that once kept human beings busy suddenly seems very small. Streets, rooms, phone screens, the sound of traffic outside the door, the crowded schedules of an ordinary day, all of it slowly contracts into a thin layer of light on the surface of the planet. The spacecraft does not travel along a simple straight line like an arrow. In space, a journey to Jupiter is not like driving from one city to another. You need to know not only where your destination is, but also how both planets are moving around the Sunday. Earth is traveling along its orbit. Jupiter is following its own path, much farther away and moving much more slowly. To reach Jupiter, a real spacecraft must be launched onto a carefully calculated trajectory, one that makes use of speed, launch timing, the gravity of the Sun, and sometimes even the gravity of other planets. On this imagined flight, we will not turn that journey into a dry mathematical problem. We only need to hold on to one simple idea. In space, traveling far is not merely a matter of accelerating forward. It is the art of falling with great precision through gravity. As Earth recedes behind you, you may begin to notice something subtle but important. We are leaving the only planet where human beings have ever stood. Breathed naturally, listened to rain, walked beneath an open sky, and looked at Jupiter as nothing more than a point of light above. From home, Jupiter sometimes appears in the night sky like a bright, steady star, with very little twinkling. To the naked eye, it reveals nothing of its clouds, storms, moons, or magnetic field. It is simply a quiet point of light. But on this journey, that point will slowly grow larger, and after a very long time, it will become an enormous world, filling nearly the entire window before you. The distance between Earth and Jupiter is not constant. Because both planets orbit the Sun, there are times when they are closer together and times when they are much farther apart. Even under favorable conditions, Jupiter is not a nearby destination. It lies in the outer region of the solar system, beyond the orbit of Mars, where sunlight is weaker than it is on Earth. From the spacecraft, the Sun would still appear intensely bright, still at the center of every motion, but it would feel different. It would no longer be the familiar great light in a blue sky. It would be a brilliant star suspended in deep blackness, slightly smaller, colder in feeling, yet still powerful enough to illuminate the giant planets far away. The spacecraft continues through the space between the planets. This is not a completely empty or meaningless void. The region between Earth and Jupiter contains dust, charged particles, sunlight, far-reaching gravitational fields, and places that human beings can understand only through instruments and measurements. But to your eyes, it may appear almost perfectly still. The darkness here is not like the darkness of a room after the lights have been turned off. It is deeper, wider, and without walls for the eye to rest upon. When you look outside, the stars do not streak past, as they often do in movies. They seem almost motionless because they are so unimaginably far away. That stillness makes the spacecraft's movement feel strangely unreal. You know you are traveling at tremendous speed, yet the universe before you remains as slow as a long breath. Behind you, Earth continues to shrink. At first, you can still see white clouds curling over the oceans, the blue of the seas, and the clear arc of the atmosphere. Then those details begin to fade. Earth becomes a shining marble. Later, it is only a pale blue point near the light of the Sunday. The sight might leave a person silent, not because of fear, but because in that moment, you understand that everything most familiar to you exists on a very small object, surrounded by an immense expanse. Yet that smallness does not make Earth less valuable. It makes the planet feel even more precious. It is a place with air gentle enough to breathe, liquid water across its surface, temperatures mild enough for life, and skies we often look up at without giving them much thought. Jupiter is different. It is not a place where a human being could step down onto the ground. It has no solid surface like Earth, no shorelines, no fields, and no mountains from which to watch a sunset. It is a gas giant composed mainly of hydrogen and helium, two light elements that have been common in the universe since its earliest history. But calling Jupiter a world of gas does not mean that it is light, gentle, or empty. With its enormous mass, powerful gravity, deep atmosphere, and pressure that rises violently as you descend, Jupiter is a world that forces us to leave behind our familiar ideas of what a planet should be. On Earth, we usually imagine a planet as a place with a surface. On Jupiter, there is no clear boundary that can truly be called the ground. What you see from a distance is only the uppermost cloud layer of a vast and complex atmosphere. Inside the cabin, the navigation system displays the long route toward the outer solar system. But for anyone imagining this journey, the exact numbers of the orbit are not what matter most. What matters is the feeling of moving from a world that can be touched to one that can only be observed. From Earth, we are traveling away from the most familiar place we know and toward a planet so large that many smaller worlds can exist within its realm of influence. Jupiter has numerous moons, storms larger than Earth, a powerful magnetic field, glowing auroras, faint rings made of dust, and a deep interior that no spacecraft could ever pass through like an ordinary flight. If this journey had a sound, it might not be the roar of engines. It would be more like the soft background hum of a room late at night, when everything has settled and you can almost hear the quiet itself. Ahead, Jupiter is not yet clearly visible. It remains a distant point of light, a destination waiting somewhere in front of us. But simply knowing that this point is the largest planet in the solar system changes the way it feels. It is no longer just a speck in the sky. It is a doorway into enormous clouds, winds that race around an entire planet, ice-covered moons, and an environment so powerful that human beings can approach it only with carefully protected machines. You may begin to wonder what Jupiter will look like if we continue flying toward it. How will it grow within the window? When will the first bands of color begin to appear? Will the great red spot truly resemble an enormous eye of a storm when seen from nearby? And as we pass through the region of its moons, will we see their shadows gliding across the clouds? These questions travel quietly with the spacecraft. They do not need to be answered quickly. On this journey, science is not a crowded list of facts. It is a way of allowing our eyes to become familiar with a distant world, and then slowly understanding why it looks the way it does. Night continues on Earth behind us. Somewhere, perhaps, a person is standing on a balcony, looking up at the sky and seeing Jupiter as a point of light. That person does not know that, in our imagination, a spacecraft is traveling toward that very point. Ahead, Between the deep darkness and the cold light of the stars, the giant planet continues to turn. It rotates remarkably quickly for a world of its size, stretching its clouds into long bands around the planet. Its storms continue to churn. Its moons continue along their orbits. Its magnetic field still reaches far into space, forming an invisible region of influence. And for now, the flight has only just begun. We have not yet seen Jupiter as a striped sphere. We have not seen the great red spot pass through the shadows of its moons or approach the auroras glowing near its poles. We have only just left our home planet, carrying the human way of seeing with us and directing it toward a world far larger than any familiar landscape. Ahead, that point of light will slowly grow, very slowly, very quietly. And when it begins to take shape, when a bright point becomes a real planet, we will understand that Jupiter is not merely a name in the solar system. It is an enormous world waiting to be seen more closely, one layer at a time. During the first days of the journey, Jupiter still has no clearly defined shape. It remains only a point of light ahead, small, steady, and almost unchanged if you watch it for just a few minutes. Against the deep black background of space, that light does not twinkle as many stars do when seen from the ground, because the atmosphere of Earth is no longer there to disturb the light before it reaches your eyes. It appears calmer and more solid, more like a distant promise than a sight that has already drawn near. If you have ever looked at Jupiter from Earth on a clear night, you may have seen it as an unusually bright star, but that is a natural misunderstanding created by the eye. Jupiter is not a star. It does not produce its own light through nuclear reactions as the Sun does. The light we see from Jupiter is sunlight reflected by the upper layers of its clouds. In other words, when you see Jupiter in the night sky, you are seeing light that traveled from the Sun to that enormous planet, touched its cold cloud tops, and then returned to your eyes after a very long journey. Inside the spacecraft, knowing this makes the point of light ahead feel different. It is not a lamp burning by itself in the darkness. It is a vast world being illuminated from far away. And because Jupiter is so large, larger than every other planet in the solar system, it can reflect enough sunlight to stand out in Earth's sky even from such a great distance. From the ground, human eyes see only a bright dot. But on this journey, that dot is slowly revealing its true size. Time passes gently. The stars in the background appear almost perfectly still. The Sun remains the brightest object in the system, but it no longer dominates your senses as it does when you live beneath a daytime sky. Beyond the window, space holds a vast silence, and within that silence, Jupiter grows little by little. At first, you notice only that it is brighter than the other points of light. Then it no longer looks entirely like a dot. It begins to show the faintest disk, a tiny circle, rather than a sharp point of light. This is an important moment in the journey. Your eyes are beginning to recognize that what lies ahead is not a star, but a planet. From this distance, the disk is still too small for any detail to be visible. Yet the difference is enough to change the feeling of the journey. A star remains far too distant for the unaided eye to see it as a disk. It is reduced to light alone. Jupiter, however, begins to gain width as the spacecraft draws closer. It has an edge. It has a side illuminated by the Sunday. It has a darker region turned away from the light. From this point on, the journey is no longer simply a flight toward a set of coordinates in space. It has become a journey toward a world with shape. As you continue forward, the first hint of color begins to appear. It does not immediately resolve into the clear bands of orange, brown, and white seen in photographs taken by space probes. At first, there is only a faint warmth within the brightness. Then one part of the planetary disk seems slightly uneven in color. Pale streaks begin to run across it, as though someone had brushed very soft lines across a glowing sphere. You cannot yet see the great red spot. You cannot yet make out the smaller swirls or the complex structures within the clouds. But you can see the first sign of Jupiter's atmosphere, the cloud bands that circle the planet. This is where one familiar misunderstanding must be left behind. The stripes on Jupiter are not land masses, oceans, or enormous continents like those on a map of Earth. They are clouds, gases, and flowing currents within a vast atmosphere. When Earth is seen from space, white clouds appear above blue oceans and green-brown continents. On Jupiter, nearly everything visible is atmosphere. There is no familiar solid surface exposed beneath it to form a map. The image of Jupiter is an image of weather, though not weather that lasts for only a few hours or days. It is the weather of a giant planet, capable of sustaining powerful wind bands and storms for extremely long periods of time. The spacecraft is still not close enough for the details to become sharp, but Jupiter now occupies a noticeable portion of the window. If Earth behind you once resembled a small marble, Jupiter ahead now looks more like a curved wall slowly drawing nearer. Not because the planet is rushing toward you, but because the spacecraft itself is following a carefully calculated path into Jupiter's region of influence. Jupiter's gravity is extremely powerful, much stronger than Earth's, and although gravity cannot be seen directly, its meaning becomes clear in the motion of everything around the planet. Moons orbit it. Dust and small particles form faint rings. Spacecraft passing through this region must follow carefully planned trajectories, because Jupiter is not simply a large sphere floating in space. It is the center of a complex and dynamic system. Through the window you may begin to notice a few small points of light near Jupiter. They do not remain fixed against the background stars. If you observe them long enough, or if the spacecraft's display identifies them, you may realize that they are some of Jupiter's largest moons. Io, Europa, Ganymede, and Callisto were once only points of light observed by Galileo from Earth more than 4 centuries ago. On this imagined journey, they are no longer merely names in the history of astronomy. They are small worlds moving around the giant planet, each carrying a story of its own. Volcanoes, ice, hidden oceans, ancient surfaces, and gravitational forces that continually stretch and reshape their interiors. But for now, we will not hurry toward the moons. Keep your attention on Jupiter a little longer. The original point of light has become a planetary disk. That disk now has color. The color now contains bands, and those bands are revealing a world that is never still. Even when its motion appears slow, Jupiter is rotating very quickly. A day on Jupiter is far shorter than a day on Earth. That rapid rotation helps stretch the atmosphere into long bands encircling the planet, almost like an enormous spinning drum drawing its cloud layers into rings. Strangely, the larger the sight becomes, the slower the story should feel. Nothing in space needs to be rushed. Jupiter had been rotating this way long before human beings gave it a name. It shone in the night skies of many civilizations. It was observed first with the naked eye, then through small telescopes, then by spacecraft flying past it, and later by advanced instruments designed to look more deeply into its clouds, magnetic field, and radiation. And now, on this quiet journey, we are doing something very simple, watching a point of light become a world. As the spacecraft moves closer still, the edge of Jupiter becomes more clearly defined. One side of the planet is illuminated by sunlight, while the other gradually disappears into a gently curving darkness. Along the boundary between day and night, the cloud bands do not vanish all at once. They fade softly into shadow, like patterns on an enormous sphere turning through its own night. The view reminds us that Jupiter also has days and nights, even though its days are short and there is no solid ground where anyone could stand and watch a sunrise. Ahead, the largest planet in the solar system is no longer merely a symbol in a textbook. It now has volume, color, motion, and small companion worlds traveling beside it. The longer you look, the more you understand that Jupiter's beauty does not belong to any single feature. It lies in the gradual transformation from distant to near, from a point of light to a tiny disk, to a patterned sphere, and finally to an immense world of clouds almost too large for the eye to take in at once. And as the bright and dark bands become clearer, our journey enters its next stage, not simply seeing Jupiter, but beginning to read the first lines of cloud across the face of the giant planet. Once Jupiter is no longer just a point of light, the first thing that may capture your attention is its size. It is vast, so vast that through the spacecraft window, the planet no longer feels like a distant object, but like an entire region of space taking over your field of view. The cloud bands stretching around its body make it seem both familiar and strange. Familiar, because we have seen this image in books, documentaries, and photographs of the solar system. Strange, because as you imagine yourself drawing closer, you begin to sense that this is not a motionless sphere. Jupiter is the center of an environment that extends far beyond the planet itself. At a glance, it is easy to think of Jupiter as a solitary world, an enormous gas giant orbiting the sun, far from Earth, cold, striped, and marked by the Great Red Spot. But as the spacecraft continues into the space surrounding it, the picture begins to widen. You no longer see Jupiter alone. You notice small points of light near the planet, some on one side, some on the other, a few close to its edge, and others farther out in the darkness. At first, they may resemble background stars. But if you watch long enough, you will notice that they do not remain completely still in relation to Jupiter. They belong to it. They are orbiting around it. This is when Jupiter begins to resemble a miniature solar system. At the center is a giant planet with powerful gravity. Around it, moons of many sizes travel along their own orbits. Farther out are dust, faint rings, charged particles, magnetic regions, and invisible lines of interaction. Jupiter, of course, is not a star. It does not shine through nuclear fusion as the Sun does, nor does it rule over the entire solar system. But within its own domain, Jupiter acts as an enormous center of gravity, holding an entire family of celestial bodies around it. Seen from nearby, it becomes easy to understand why astronomers have long regarded the Jovian system as one of the most fascinating places to study beyond Earth. Jupiter's 4 largest moons are known as the Galilean moons: Io, Europa, Ganymede, and Callisto. Galileo Galilei observed them through a telescope in the early 17th century, and that discovery changed the way humanity understood the universe. Before then, many people were still accustomed to the belief that everything in the sky must revolve around Earth. But when Galileo saw those tiny points of light changing position around Jupiter from one night to the next, he realized that they were orbiting another planet. This was more than a small astronomical detail. It was evidence that Earth was not the only center of motion in the universe. On this imagined journey, those 4 points of light are no longer merely a note in the history of astronomy. They are real worlds drifting through Jupiter's gravitational realm. Io lies closer in, exposed to powerful forces and known for its intense volcanic activity. Europa appears colder and brighter, covered in ice and intriguing us with the possibility of a liquid water ocean beneath its crust. Ganymede is larger in diameter than Mercury and is the largest moon in the solar system. Callisto orbits farther away, heavily scarred by impact craters, like an ancient surface, preserving countless traces of time. For now, we only need to see them as Jupiter's 4 great companions. Their individual stories will unfold later, but their presence alone already makes this giant planet feel very different from a solitary sphere. From the spacecraft window, if the observation system were to trace the moon's orbits, you would see a scene of remarkable order. Imaginary curves would surround Jupiter, each one forming a long path through space. The moons do not fall directly into the planet, nor do they escape into the darkness. They are continuously falling around Jupiter, in the same way that the moon falls around Earth and Earth falls around the Sunday. This is one of the simplest ways to understand an orbit. An object is falling, but it is also moving sideways fast enough to keep missing the place where it would otherwise land. The result is a circling motion that can remain stable for a very long time. Seen this way, the view becomes gentler. The moons are not merely rock and ice flying through space. They are bodies held in an ancient and enduring motion by gravity. Jupiter pulls them inward, while they continue moving forward along their paths. Between the inward pull and the forward motion, the orbit remains. There is no visible string and no track beneath them, only gravity and movement. The scale may be enormous, but the image is familiar. It is somewhat like tying a small object to a string and swinging it around your hand. The object naturally wants to move in a straight line, while the string pulls it inward. In space, there is no string to be seen. Gravity performs that work in silence. The Jovian system contains far more than these 4 large moons. Jupiter has many smaller moons as well, some traveling along close orbits, others much farther away, and some following more complicated paths. Not every moon is large, round, or easy to see. Many of the smaller ones may resemble captured pieces of rock or fragments left behind by collisions in the distant past. Yet this very diversity makes Jupiter feel more like a system than a single object. At the center is the giant planet. Around it are large moons, small moons, dust, plasma, and patterns of interaction that cannot be seen with the unaided eye. Jupiter also has rings. They are not the broad, bright, easily recognized rings of Saturn. Jupiter's rings are much thinner and far fainter, composed mainly of tiny particles of dust. Unless the light strikes them at the right angle, you might barely notice them at all. yet they are still there, like a very fine layer of powder surrounding the planet. At some point, as the spacecraft passes through a position where sunlight skims across the dust, the faint rings may appear softly, almost like a thin ribbon of smoke in the darkness. They are not spectacularly bright, but their subtlety makes the view feel more real. The universe does not always reveal everything clearly. Some structures appear only when we look from the right direction. Beyond everything the eye can see, Jupiter is surrounded by an enormous magnetosphere. This is the region of space controlled by the planet's magnetic field. If magnetic fields were visible like light, Jupiter would not appear merely as a sphere through the window. It would seem enclosed within a vast, invisible bubble, extending far into space, and pushed into an uneven shape by the solar wind. This magnetic field traps and guides charged particles, creates an intense radiation environment, and helps produce the auroras near Jupiter's poles. Your eyes may not see this region directly, but the spacecraft's instruments would know very clearly that the ship had entered a different kind of environment. This makes Jupiter feel even more like a realm of its own. There is not only the planet, not only the moons, and not only the dusty rings. There is also an entire invisible region of influence surrounding them. On Earth, we are accustomed to thinking that a planet ends at its surface, or perhaps at the upper edge of its thin atmosphere. With Jupiter, that idea is not enough. The planet extends outward, through gravity and magnetism. It affects the orbits of its moons, the volcanoes of Io, the ice of Europa, the dust particles within its rings, and the charged particles moving through the surrounding space. A large part of Jupiter's story is not found at the cloud tops, but in the relationships between the planet and everything traveling around it. From a distance, the Jovian system might be imagined as a great city at night. Jupiter is its brightest, heaviest, and largest center. The major moons are like important districts surrounding that center, each with its own character. The smaller moons resemble distant neighborhoods, harder to see but still part of the same network. The dusty rings are like a very faint road, visible only when light passes across them at the proper angle. The magnetic field is like invisible infrastructure, absent from any ordinary visual map, yet shaping much of the movement within. And our spacecraft, very small by comparison, is crossing into the boundary of that city. This feels very different from looking at a single photograph of Jupiter. In an image, the planet usually stands alone at the center of the frame. We see its cloud bands, the great red spot, and the beauty of its visible atmosphere. But when you imagine flying closer, you realize that Jupiter does not exist in isolation. Motion surrounds it. One moon passes in front of the planet. A round shadow may glide across the clouds. Another moon disappears behind Jupiter and later emerges again. A faint dust ring lies almost hidden in darkness. Charged particles travel along magnetic field lines. Together, these motions make Jupiter a physically dynamic system, even though they are not signs of biological life. This is also why many missions are interested not only in Jupiter itself, but in its entire system. To understand Jupiter, we must study its moons. To understand the moons, we must understand Jupiter's gravity. To understand the environment around them, we must examine magnetic fields, radiation, charged particles, and the history of collisions. Everything is connected. A gas giant can create a region of study so vast that nearly every part of it feels like a separate world. Inside the spacecraft, the observation screen may display the names Io, Europa, Ganymede, and Callisto. But even without looking at the labels, simply gazing through the window would reveal the most basic truth. Jupiter has companions. It has rhythms of motion around it. It possesses a region of space all its own, and once the spacecraft enters it, the journey is no longer merely a flight past a planet. It has become a passage into a smaller system contained within the greater solar system. It is a gentle thought, but also a very expansive one. Throughout the universe, structures often repeat at different scales. The sun has planets. Planets have moons. Those moons in turn have surfaces, ice, volcanoes, hidden oceans, or long histories of impacts. Each time we look more closely, a world that once seemed simple opens into many layers. Jupiter continues to grow larger ahead. Its cloud bands are becoming clearer, and the bright and dark regions are beginning to take shape with soft, flowing boundaries. The small points of light around it no longer seem like visual noise against the window, but like celestial bodies with names, orbits, and histories of their own. The spacecraft is drawing closer to the center of this smaller system, while still maintaining a safe distance. The more we understand Jupiter, the more clearly we see that its beauty is inseparable from its power. Its gravity is strong, its magnetic field stretches across an enormous region. The radiation around it can be dangerous. The storms within its atmosphere are larger than any storm on Earth. This is not a place where human beings could step onto the ground, but it is a place where curiosity can pass by slowly. And when you take in the entire scene, Jupiter no longer feels like merely the fifth planet from the Sunday. It appears more like a great center in the darkness, a place where many kinds of motion come together. A vast sphere of gas rotating rapidly. 4 large moons like bright points traveling along ancient orbital paths. Many smaller moons hidden farther away. A thin ring of dust that is almost invisible. An immense magnetic field surrounding them all. It is a system that feels familiar because it follows the laws of gravity, yet deeply unfamiliar because its scale and conditions are so different from anything on Earth. From here, our journey will move closer to the most visible part of the planet, its cloud bands. If the Jovian system resembles a miniature solar system, then Jupiter's cloud tops are the first face that human beings see. Those bright and dark stripes are not decoration. They are traces of an atmosphere in motion, shaped by wind, heat, rapid rotation, and powerful currents flowing around a giant planet. We have seen that Jupiter has an entire family surrounding it. Now, let us bring our attention back to its cloud-covered surface, where the bands of color begin to tell the story of weather on a world without solid ground. At some point in the journey, Jupiter is no longer an object lying far ahead. It begins to become an entire sky. Before this, you could still see the planet as a sphere suspended against the darkness, with a clear edge, a sunlit face, and small points of light from its moons nearby. But as the spacecraft draws closer, that impression changes very slowly. Jupiter continues to grow until your eyes can no longer take in the whole planet at once. It no longer looks like a world contained within the window. Instead, it feels as though the window itself has opened onto an immense curved wall of clouds. The first thing you may feel is not fear, but a kind of imbalance in the imagination. On Earth, we are accustomed to objects whose size can still be understood in relation to the human body. A house may be large, a mountain may be high, and an ocean may be vast. But all of them still belong to a world where we can stand and measure distance through our own experience. Jupiter is different. It is so large that familiar scales begin to lose their meaning. If Earth were placed beside Jupiter, our home planet would look like a small sphere next to something enormous. Jupiter is about 11 times wider than Earth, and its mass is greater than the combined mass of all the other planets in the solar system. Yet even those numbers cannot fully create the feeling of its size. Only when you imagine it filling the window do you begin to sense that vastness with your own eyes. Below the spacecraft, there are no continents, no blue oceans, no coastlines, deserts, forests, mountains, or polar ice like those we see when looking at Earth from space. Instead, cloud bands stretch all the way around the planet, alternating between light and dark, gently following the curve of an immense sphere. Some regions are creamy white, others are reddish-brown. In some places, pale yellow blends into orange, while elsewhere the colors appear grayer and deeper. These shades do not sit still like paint on a solid surface. They are part of a moving atmosphere. They are clouds, winds, and the uppermost layers of a world with no clear ground for the eye to rest upon. If Earth seen from space often makes us think of life, water, and the fragile thinness of its atmosphere, Jupiter seen from nearby creates a different feeling. The weight of a giant planet. It is not blue and gentle like Earth. It does not appear cold and still like the Moon. Nor does it have the dusty red surface of Mars. Jupiter resembles a rotating ocean of atmosphere, and we are seeing only the tops of its upper cloud layers. Yet beneath those clouds, there is no solid ground waiting to be reached. The deeper you go, the greater the pressure becomes. The temperature rises, and matter gradually moves away from the familiar states we know in everyday life. This makes the first wide view especially striking. Jupiter is beautiful, but its beauty does not invite human beings to land. It is the beauty of a place too large and too powerful to become a home. The spacecraft maintains a safe distance. In your imagination, you may be sitting quietly beside the window, but everything outside is in motion. Jupiter rotates extremely quickly. One day on the planet lasts less than 10 Earth hours, far shorter than its immense size might lead you to expect. This rapid rotation helps draw the atmosphere into long bands that circle the planet. The patterns before you are not decoration. They are traces of a world turning, where winds move east and west, where different regions of gas slide past one another, and where cloud vortices form, stretch, fade, and are replaced by new structures. From this distance, your eyes begin to distinguish the bright and dark regions more clearly. The brighter bands are usually called zones, while the darker bands are known as belts. But before remembering those names, simply see them as flowing currents. They wrap around Jupiter almost horizontally, embracing the planet like extremely long rivers of cloud. Some appear soft and bright, others seem darker and heavier. Along certain boundaries, the edges are torn into smaller swirls. From far away, Jupiter's stripes look neat and orderly. Seen more closely, they are neither flat nor simple. They contain ripples, waves, curls, small breaks, and regions where colors blend together like ink dissolving in water. The view may remind you of clouds seen from an airplane above Earth, but that comparison works only at first glance. Earth's clouds move above a planet with solid land and oceans beneath them. They drift across continents, mountains, and seas, shaped by terrain, seasons, temperature, and water. Jupiter's clouds exist within a far deeper atmosphere, composed mainly of hydrogen and helium, with different chemical cloud layers and wind currents that can extend for thousands, even tens of thousands, of miles. When you look at Jupiter, you are not seeing weather taking place on the surface of a planet. You are seeing the planet itself as one enormous weather system. Slowly, the spacecraft passes across the side illuminated by the sunday. The light is not harsh, as it might be when reflected from ice or metal. It is softer because it comes from the cloud tops. The brighter regions catch the sunlight gently, while the darker ones absorb more of it, giving the planet a sense of depth. Jupiter's far edge curves into darkness. There, the cloud bands do not disappear suddenly. They fade gradually, like a multicolored fabric being drawn into night. The boundary between day and night on Jupiter is not a cold, sharp line. It is a gentle transition where the colors slowly dim. If the spacecraft could display a scale across the window, you would see that details that appear small on Jupiter are actually enormous. A minor cloud vortex that your eyes pass over may be as wide as an entire country on Earth. A curve within one band may stretch farther than the distance between several continents. A pale region that seems like nothing more than a streak of color may be the upper portion of a vast cloud system. This is one reason Jupiter is so difficult to imagine. Everything appears patterned, yet every pattern exists on a planetary scale. The human eye is accustomed to compact images, so it needs time to understand that these cloud markings are not decoration. They are the geography of a planet without land. Even the word geography is only borrowed here. Jupiter has no map in the earthly sense. There are no land boundaries, no oceans to name, and no fixed mountain ranges. Everything we see is always changing, even though some large structures can survive for a very long time. If you flew past Jupiter today and returned much later, the planet would still have its main bands and its broad divisions between light and dark, but many of the smaller cloud details would be different. It is more like looking at a living face than at a statue. Jupiter's appearance has order, but that order is continually being created through motion. In the silence of the cabin, the sight before you may make the small concerns of the day feel a little lighter. Not because they do not matter, but because the scale outside is so immense. A planet like Jupiter does not move according to human time. It rotates in its own rhythm, holds moons in orbit, stretches clouds into bands, sustains storms that last for years, and extends its influence across a vast region of space. Seen from nearby, you do not need to view the entire planet to know that you are standing before something enormous. The fact that you cannot see all of it is enough. Perhaps you try to find a place where your eyes can rest. On Earth, when we look at a landscape, our gaze can settle on a horizon, a tree, a mountain peak, or a house. On Jupiter, that point of reference continually drifts away. One cloud band leads into another. A bright streak dissolves into a brown vortex. A dark region follows the curve of the planet and disappears beyond the edge of the window. There is no horizon like the one we know from standing on solid ground. There is no familiar sense of above and below. There is only an immense sphere of clouds, curved, deep, and turning. If the spacecraft passes at the right angle, you may see the planet's own shadow stretching behind it, darkening part of the surrounding space. One or two small moons may appear near the edge, delicate points of light beside the enormous body of clouds. The contrast is striking. The moons look small and sharply defined, like pieces of rock or ice illuminated by the sunday. Jupiter appears softer, with no exposed solid surface, yet it is far more powerful in mass and gravity. On one side are worlds with crusts, craters, ice, or volcanoes. On the other is a giant gas planet whose surface is simply the cloud layer the human eye chooses as a place to begin. This first wide view is important because it reshapes the way we imagine Jupiter. Perhaps, until now, the planet existed in your mind as a brown and orange sphere marked by a red spot, a beautiful image, but a flat one. Seen from nearby, it is no longer flat. It has depth. The cloud bands have texture. The bright and dark regions have layers. The planet's edge falls into shadow. Its illuminated face changes with the viewing angle. The small moons surrounding it create the sense that Jupiter is a center rather than an isolated object. And above all, its size changes the meaning of every detail. What appears to be a thin streak may be an atmospheric region far larger than many places on Earth. Let the sight remain for a little while. There is no need to hurry toward the planet's most famous storm. There is no need to search for the great red spot just yet. Before examining one extraordinary feature, the eyes need time to adjust to the planet as a whole. An immense sphere of cloud, glowing beneath distant sunlight and rotating rapidly through darkness. Its cloud bands circle it like roads with no beginning and no end. The colors are not intensely bright, but they are deep enough to suggest the layers of matter below. And all of it is unfolding within a silence that only space can create. From here, our journey will carry us closer to those cloud bands. We will begin to distinguish the belts and zones more clearly, understand why Jupiter is wrapped in long, nearly parallel stripes, and explore how a gas giant can sustain weather structures on such an enormous scale. But before we turn to the forces behind them, keep this first image in mind. Jupiter is no longer a point of light in the sky, and no longer a picture in a book. It is directly before you now, too large to take in all at once, too unfamiliar to feel ordinary, and too beautiful to be dismissed as nothing more than a simple sphere of gas. When Jupiter fills nearly the entire window, its size is no longer the only thing holding your attention. An enormous sphere may feel overwhelming for the first few moments, but what keeps your eyes there are the patterns stretching across the planet. They are not arranged at random. They do not resemble the scattered clouds carried by winds across Earth. Instead, they form long bands, running almost parallel to the equator and circling Jupiter like immense rivers within the atmosphere. Some bands are bright, while others are dark. There are regions of creamy white, reddish-brown, pale yellow, muted orange, and gray, and the boundaries between them are anything but calm. If you watch for long enough, you will see cloud edges drawn into threads, torn into waves, curled into smaller vortices, and then blended into neighboring layers of gas like ink slowly dissolving in water. Scientists call the darker bands belts and the brighter regions zones. But before remembering those terms, imagine something simpler. Jupiter's atmosphere is not a motionless blanket of clouds wrapped around the planet. It is more like a system of enormous currents, where streams of gas wider than many countries on Earth move around the planet in different directions. Some regions appear brighter because their higher, thicker clouds reflect sunlight more effectively. Other regions look darker because we are seeing deeper into different cloud layers, or because their composition, altitude, and cloud structure are different. As all these regions are stretched around a rapidly rotating planet, they create Jupiter's famous striped appearance. The important thing to remember is that these stripes are not a surface. On a map of Earth, blue represents oceans, green and brown mark continents, and white may indicate ice or clouds. On Jupiter, nearly everything you can see belongs to the atmosphere. There are no coastlines beneath the bright bands, no plateaus under the brown ones, and no exposed solid ground dividing the planet into fixed geographical regions. What your eyes interpret as shape is really weather and motion. Jupiter does not have a map in the way Earth does. It has a map of wind, and the winds on Jupiter are nothing like the breeze outside your window. On Earth, When we think of powerful winds, we imagine trees bending, rough seas, rooftops shaking, or rain striking the glass. Yet those winds still move across a planet with land and oceans below, with terrain that redirects them, seasons that reshape them, and temperature differences between land and sea. On Jupiter, winds flow through a deep, dense atmosphere without a familiar solid surface to slow them down. Vast currents can race eastward or westward around the planet, forming jet streams along the boundaries between the belts and zones. These jet streams help prevent the cloud bands from blending completely together. They act like shifting borders, both separating the regions and disturbing the gases on either side. Look closely at the boundary between a bright zone and a darker belt. From far away, it may seem like a soft, simple line. But if the spacecraft moves closer, or if the camera magnifies the view, that boundary becomes much more complex. It has waves, bends, and patches of cloud stretched into delicate threads. In some places, the flow looks smooth and steady. In others, it breaks into turbulence. This matters because it shows that Jupiter's atmosphere is not merely arranged into attractive stripes. It is active. It contains a constant tension between order and chaos. The winds try to hold the clouds in long bands, while vortices, smaller storms, atmospheric waves, and temperature differences continually reshape their edges. One of the main reasons Jupiter has such distinct bands is its rapid rotation. Although it is far larger than Earth, Jupiter completes one full turn in less than 10 hours. Pause with that thought for a moment. A giant planet, large enough to hold more than 1,000 Earths by volume, spins so quickly that one of its days is shorter than a long human workday. This rapid rotation has a powerful effect on the atmosphere. It organizes the motion of gases around the planet, producing bands that run parallel to the equator. On a more slowly rotating world, the atmosphere might behave differently, but on Jupiter, the fast rotation acts like an invisible hand, drawing the cloud currents into rings. A familiar image may help. When you stir a cup of tea, the liquid begins to rotate, pulling streaks of color or swirls of milk into curved patterns. But Jupiter is not a small cup of tea. It is an enormous gas giant rotating continuously, with internal heat, sunlight arriving from outside, powerful gravity, and deep layers of gas stacked one above another. Its cloud bands are not created by one simple stirring motion, but by many processes working together: rotation, convection, temperature differences, chemical composition, cloud formation, jet streams, and deeper atmospheric dynamics beneath the clouds we can see. When we look at the zones, the brighter regions, we are often seeing higher, more reflective clouds. Some of these clouds are connected to ammonia, which can form ice crystals in Jupiter's cold upper atmosphere. These bright areas can be understood as places where gas rises, cools, and helps brighter clouds form at higher altitudes. The belts, the darker regions, often give us a deeper view into the atmosphere, where the bright upper clouds may be thinner or where the atmospheric structure is different. But this needs to be stated carefully. Jupiter is not a simple two-color picture, and belts and zones do not differ for only one reason. They result from both atmospheric motion and cloud chemistry. That is why spacecraft such as Juno do more than photograph the visible surface. They also use instruments to look deeper, exploring how far these bright and dark bands extend below the clouds and how they change with depth. This is where the science becomes even more fascinating. With the naked eye, you might simply say that Jupiter has stripes. Science asks what lies beneath them. How deep do those bands extend? Are they only thin cloud patterns near the top? Or are they traces of currents reaching far down into the atmosphere? Why is one band brighter than another? Why do some regions remain stable for years, while smaller details may change within days? How can the atmosphere of a planet, without a solid surface, create structures so long, so clear, and so persistent? Questions like these transform a beautiful image into a scientific story. If the spacecraft were to travel alongside one of the cloud bands, it might feel as though you were flying beside a river with no banks. But this river is not made of water, it is made of gas. It does not flow across the ground, but around an entire planet, and its two shores are not still. One side may be a brighter region of rising gas, while the other is darker, with a powerful current sliding between them. Looking closely, you might see small oval vortices, white streaks, clouds drawn into threads, and wave-like edges resembling fabric caught in the wind. Some vortices may survive only briefly. Other structures can endure much longer. And somewhere farther across the planet, a storm as immense as the Great Red Spot is still waiting for us later in the journey. Before reaching that storm, however, let us remain with the cloud bands for a little longer, because they are the key to understanding Jupiter. The Great Red Spot is famous, but it does not exist outside the larger system. It is part of an atmosphere shaped by the same forces that create the belts and zones. If we look at the Great Red Spot only as a remarkable isolated feature, we may miss the greater foundation beneath it. Jupiter as a whole is a natural laboratory for fluids, atmospheres, and motion on a rapidly rotating planet. Its cloud bands are the visible evidence of that laboratory at work. On Earth, we have only one atmosphere in which we can live and observe directly. Jupiter offers a completely different example of how an atmosphere can behave under extreme conditions. There is no solid surface like ours. The gases have a different composition. Pressure and temperature change in profound ways with depth. Heat from the planet's interior still plays an important role. The rotation is extremely fast, and Jupiter's enormous size allows weather systems to develop on scales that have no direct equivalent on Earth. Studying its belts and zones is therefore not only about understanding why Jupiter looks beautiful, it also helps scientists learn more about atmospheric dynamics, giant planets, and the ways large worlds beyond our solar system may behave. This has an even broader value. Humanity has now discovered many exoplanets, including numerous gas giants orbiting other stars. We cannot travel close to them as we can to Jupiter. Most of the time, we detect only very small signals, a slight dimming of starlight as a planet passes in front of its star, or a spectrum that reveals part of its atmosphere. Jupiter is far closer than any of those distant worlds, making it an important model for learning how giant planetary atmospheres work. When we study Jupiter's cloud bands, we are not only examining a planet within our own solar system, we are learning a language that may help us interpret faraway worlds circling other stars. From the spacecraft window, all of this can be felt in a much simpler way. A bright cloud band stretches across your view. Beneath it lies a darker one. Between them, thin strands of cloud are pulled apart, twisted, and scattered. You do not need to see equations to understand that forces are at work. You do not need to hear the wind to know that the atmosphere is moving. And you do not need to stand on Jupiter, because there is no easy place there to stand. Simply by looking, you can already see the traces of physics: rotation, flow, pressure, heat, cloud chemistry, gravity, and time. There is a special kind of beauty in understanding what you are seeing. Before we know the science, Jupiter's stripes may seem like nothing more than patterns. After learning a little, they become a story. Each bright and dark band is the visible edge of a much deeper system. Every region of color is shaped by matter rising, sinking, being pulled sideways, cooling, reflecting sunlight, or becoming visible through different layers of the atmosphere. Every rippling boundary reminds us that an atmosphere does not like to remain still. It is always moving, seeking balance, breaking that balance, and then creating a new kind of order. If you continue watching, you may notice something gentle but important. Jupiter does not need life in order to feel alive. It has no forests, no blue seas, and no birds passing through its clouds. Yet its atmosphere still has rhythm, currents, structure, and change. A planet can be profoundly different from Earth without being simple. This is one of the gifts of planetary science. It teaches us that a world does not need to resemble our home in order to deserve our attention. Some worlds may be impossible to inhabit, yet they still hold deep stories about matter, motion, and time. The spacecraft continues gliding above the cloud bands. From one angle, Jupiter resembles an enormous sheet of fabric stretched around a sphere. From another, it looks like an ocean without water, where powerful currents endlessly circle the planet. Bright and dark regions shift along Jupiter's curve, gradually disappearing at the edge of night, before emerging again on the sunlit side. No sound of wind enters the cabin. There is no trembling or turbulence. There is only the sight of an immense atmosphere flowing beneath you, silent to your eyes but violent in its nature. And this is what keeps us looking at Jupiter. The longer we watch, the more we realize that we have not truly seen all of it. A stripe is never merely a stripe. A bright region is more than a patch of light. A cloud boundary is not simply a beautiful curve. Everything is a sign of deeper science below. Travel a little farther, and the bands begin to grow more tangled. Smaller vortices appear more frequently. Regions of color twist into one another with greater force. And somewhere across that giant planet, a red storm has endured through many generations of human observation, large enough to make every storm on Earth seem small by comparison. But before we approach the great red spot, hold on to the image of the belts and zones as Jupiter's underlying rhythm. They are the planet's visible breathing pattern. They tell us that Jupiter is rotating rapidly, its atmosphere is flowing, clouds are forming, and matter is constantly moving. They reveal that the planet's appearance is an ongoing process, not a layer of paint. As you fly past Jupiter, you will not simply see a striped sphere. You will see an immense atmospheric system riding long lines of wind, heat, and time across itself. As we fly above Jupiter's bright and dark bands, the easiest way to describe everything below is with one familiar word: clouds. White clouds, brown clouds, yellow and orange clouds, long streaks stretched across the atmosphere, masses curling into one another, and bright regions reflecting sunlight. From the spacecraft window, the word cloud feels natural because human eyes are accustomed to seeing clouds on Earth. We have watched them drift across blue skies, gather heavily before a storm, and shine beneath an airplane's wings. But on Jupiter, holding too closely to that familiar image can quickly lead us in the wrong direction. Jupiter's clouds are not soft white shapes, floating through an ordinary sky. They do not pass above forests, oceans, mountains, or cities. They are the visible part of a deep atmosphere, cold near the top but increasingly intense farther down, composed mainly of hydrogen and helium. These two gases are very light, extremely common throughout the universe, and also form the main ingredients of the sundae. Jupiter did not become a star, however, because it lacks the mass needed to sustain nuclear fusion as the Sun does. It is a gas giant, and its cloud layers form where different chemicals condense under different conditions and at different altitudes. Imagine Jupiter's atmosphere as an enormous building with no clearly defined solid floors. Near the top, where temperatures are colder and pressures are lower, certain substances can freeze or condense into tiny cloud particles. Deeper down, where pressure and temperature are higher, other materials form different layers of cloud. Farther below, the conditions continue to change. So when you look at Jupiter's upper cloud bands, you are not simply seeing a thin layer of white mist. You are seeing the roof of a many-layered structure, where chemistry, temperature, pressure, and atmospheric motion all help determine the colors and shapes above. One important substance in Jupiter's highest cloud layers is ammonia. At sufficiently low temperatures, ammonia can form tiny ice crystals that help make some cloud regions appear brighter. But ammonia is not the only substance involved. Lower down, there may be cloud layers connected to ammonium hydrosulfide, a compound far less familiar in everyday life than water. Deeper still, where the conditions are right, water clouds can also form. This means that Jupiter's clouds are not a single thing. They consist of several different layers, each forming at its own depth, temperature, pressure, and chemical composition. This difference matters. On Earth, clouds are made mainly of water, either as tiny liquid droplets or ice crystals. Although they appear in many forms, from thin sheets of cloud to towering thunderheads, they remain part of the familiar water cycle: evaporation, condensation, rain, and the return of water to oceans, rivers, soil, and the atmosphere. Jupiter has no surface ocean from which water evaporates in the earthly sense. It has no ground where rain can fall in the way we know. Its cloud layers form as material from the deep atmosphere rises, cools, reacts, condenses, sinks, and is drawn once again into larger currents. By sight alone, it is not easy to know what each cloud layer contains. White does not automatically mean water. Brown does not necessarily mean dust or soil. Orange is not sand, nor is it sunlight reflecting from a rocky surface. Jupiter's colors arise from a mixture of chemical composition, cloud altitude, sunlight, tiny particles in the atmosphere, and complex reactions that scientists are still working to understand. This is part of what makes Jupiter feel both familiar and difficult. It gives us a remarkably clear image, but that image cannot be interpreted through ordinary human experience on Earth. As the spacecraft glides over a bright region, you might imagine that higher, colder cloud tops lie beneath you, reflecting sunlight more effectively. But passing over a darker region does not mean there is dark ground below. It may be a place where we can see more deeply into the atmosphere, where the bright upper clouds are thinner, or where the composition and altitude of the cloud layers are different. A dark region on Jupiter can resemble a window opening into deeper levels of the atmosphere. But what lies below is still gas, cloud, pressure, and motion, not solid land. To understand these cloud layers, scientists do not rely only on ordinary color images. They observe Jupiter in several different ways, almost like viewing the same room under different kinds of light. In visible light, we see color and shape. In infrared, we can identify warmer and colder regions, along with areas where the clouds may be thicker or thinner. At microwave wavelengths, some cloud layers become almost transparent, allowing instruments to look farther into the atmosphere and measure signals related to water and ammonia. This is especially revealing because it shows that the beautiful picture, visible to human eyes, is only a small part of the whole. Jupiter has another hidden picture beneath it, one that appears only when we use the right kind of scientific vision. NASA's Juno spacecraft has helped expand this way of seeing. It did not simply fly past Jupiter to capture beautiful photographs of the cloud bands. It carried instruments capable of measuring gravity, magnetic fields, radiation, infrared light, and microwaves. Because of this, scientists can ask not only, what does Jupiter look like, but also, how deeply do these cloud bands extend? How is water distributed through the atmosphere? How is ammonia carried upward or drawn downward? And how are Jupiter's storms connected to the cloud layers below? This is part of what makes planetary science so compelling. An image that seems intended only to be admired can become an entrance into deeper questions about the internal structure of a planet. One intriguing discovery from Juno involves a phenomenon known as shallow lightning. On Earth, lightning usually forms within water clouds, where ice particles, droplets, and moving air separate electrical charges. On Jupiter, Juno has shown that lightning may occur at higher altitudes than scientists once expected, inside clouds containing a mixture of ammonia and water. Ammonia can allow water to remain liquid under colder conditions, somewhat like a substance that changes the way a mixture freezes. In an unfamiliar atmospheric world like Jupiter, even lightning is not entirely the same as lightning on Earth. It is a small but powerful example of a familiar-looking phenomenon, produced by a very different environment and mechanism. Imagine the spacecraft passing above a bright cloud region. No sound from below reaches the cabin. But if you could hear Jupiter's atmosphere, it would probably be far less peaceful than it appears. Somewhere within the deeper layers, gas is rising. Elsewhere, material is sinking. Cloud particles form and are carried away. Jet streams slide past one another. Storms lift powerful columns of gas. Lightning may flash inside cloud layers that the human eye cannot see directly. Chemical compounds are mixed, separated, cooled, and then carried down toward other depths. The scene before you looks soft, but within it is a system that never stops working. This helps us understand why Jupiter should not be imagined as a simple, smooth, and uniform sphere of gas. It is not merely a ball filled with hydrogen and helium and decorated with a few colored stripes. It has structure, it has layers, it has weather. Its clouds rise to different altitudes, its atmosphere changes with latitude, its storms can endure, and deep currents move beneath the visible cloud tops. Chemical processes unfold under conditions the human body could never survive. When we call Jupiter a gas planet, we should not interpret the word gas as meaning light or empty. On Jupiter's scale, gas can be compressed, become extremely dense, grow hotter, change its physical state, and form a world entirely unlike anything in ordinary human experience. Jupiter's clouds also remind us that color in the universe is often a form of information. A beautiful image is not only beautiful. A bright color may offer clues about a cloud's altitude, thickness, or ability to reflect light. A darker region may reveal how deeply we can see or suggest a different composition. Curling streaks show where gas is being stretched and twisted. Small spots may be vortices. Thick white regions may be connected to storms pushing material toward higher altitudes. Seen in this way, we are not merely admiring an image of Jupiter. we are learning how to read the atmosphere of a distant planet. A gentle comparison can be made with a cup of coffee and milk turning in a slow swirl. Without knowing anything about the motion, we may see only beautiful streaks of color. But by watching carefully, we can notice the currents, the places where the liquid curls inward, where it thins, and where it stretches into threads. On Jupiter, that cup of coffee is the size of a planet. The liquid is replaced by gas, the milk by cloud particles and chemical compounds, and the motion is not created by a spoon, but by rapid rotation, internal heat, gravity, and atmospheric dynamics. The comparison is not perfect, but it helps us feel one important truth. The shape of a cloud is a trace left behind by motion. In some regions, the clouds appear smooth and extended, as though they have been brushed in a single direction. Elsewhere, they are tangled and curled, like fabric gently crumpled, and then allowed to drift. These differences do more than give Jupiter its beauty. They show us that the atmosphere is not uniform. Some places are more stable, while others are more turbulent. In some regions, rising gas creates bright clouds. In others, sinking gas reveals deeper layers. Along certain boundaries, the bands are stretched into waves. Elsewhere, cloud vortices hold their shape for long periods of time. Every detail is a small sign of the much larger environment below. The more we understand these cloud layers, the less Jupiter feels like a distant background object in the solar system. It becomes a natural laboratory. On Earth, we study the atmosphere to understand weather, climate, storms, clouds, and the water cycle. On Jupiter, we study a completely different kind of atmosphere, one with no clearly defined solid surface, composed mainly of hydrogen and helium, filled with multiple layers of chemically distinct clouds, winds that encircle the planet, lightning that may form in mixtures of ammonia and water, and storms of enormous scale. By comparing these two worlds, we do not only learn about Jupiter, we learn about the many different ways a planetary atmosphere can behave. This is also important for understanding planets beyond our solar system. Many known exoplanets are gas giants, and some are even larger than Jupiter or orbit extremely close to their stars. We cannot see their clouds as clearly as we can see Jupiter's. But by understanding a nearby gas giant, scientists gain a stronger foundation for interpreting signals from those distant worlds. Clouds, atmospheric composition, temperature, reflected light, and the movement of gases are all pieces of the larger puzzle of how planets work. So when we study Jupiter's ammonia clouds and deep atmospheric layers, we are also learning how to ask better questions about countless other worlds throughout the galaxy. Through the spacecraft window, the view continues to unfold very slowly. A bright cloud band passes below. Beneath it lies a reddish-brown region. A small curling pattern turns along the boundary between two layers of color. You know that your eyes are seeing only the highest part of a system extending far deeper. Below that bright region may be other chemical cloud layers. Farther down, the pressure increases. Deeper still, hydrogen and helium no longer resemble the gases we know inside an ordinary room. The farther we descend into Jupiter, the more the planet departs from the familiar world. And this is what makes its upper clouds resemble a curtain. They allow us to see the planet, while hiding most of it from view. There is a quiet humility in the way science approaches Jupiter. We cannot simply look and rush to a conclusion. A single color may have several possible causes. A cloud may lie at a different altitude than we first assume. A bright region may change over time. A measurement at one wavelength can reveal something that an ordinary color image cannot. Understanding Jupiter, therefore, requires many kinds of data to be brought together. Images, spectra, microwave and infrared measurements, gravitational and magnetic fields, atmospheric models, and observations gathered during flybys at different distances. No single piece tells the entire story, but placed together, they gradually bring the giant planet into clearer focus. And as you continue looking down, the word cloud no longer feels as simple as it did at first. It is no longer merely something white and soft floating in the sky. On Jupiter, clouds are chemistry taking shape. They are temperature written in color. They are pressure expressed through depth. They are the movement of gases stretched into long streaks. They are signs of processes that human beings cannot feel directly against the skin, but can still understand through instruments, models, and curiosity. The journey remains above the cloud tops. The spacecraft does not descend into the deeper atmosphere. because that would not be a safe place for any imagined vehicle hoping to remain intact. Yet simply by passing overhead, we have already seen enough to know that Jupiter is not a simple ball of cloud. It is a planet whose visible exterior is weather, whose colors are data, and whose beauty is only the visible portion of a much deeper physical system. Ahead, the cloud bands begin to curl more powerfully. The bright and dark lines no longer flow quietly across the planet. Far in the distance, a larger vortex begins to emerge, where shades of red and brown blend into an immense oval. It does not yet fill the window, but it is already large enough to draw your eyes toward it. Now that we understand how Jupiter's clouds form from chemical layers and deep atmospheric motion, we are ready to witness one of the most powerful expressions of that atmosphere. A storm that has endured for a very long time, so vast that Earth itself becomes small in the imagination. The Great Red Spot is waiting ahead. After flying above Jupiter's bright and dark cloud bands, your eyes begin to grow familiar with the face of this giant planet. The white, pale yellow, reddish-brown, and gray-orange regions no longer seem like beautiful patterns alone. You now understand that they are layers of chemically distinct clouds, an atmosphere in motion, and visible traces of wind, heat, pressure, and composition. Then, far below the window, another shape begins to emerge. It does not stretch across the planet like an ordinary cloud band, nor does it blend completely into Jupiter's horizontal stripes. It is an immense oval, deeper in red and orange, resting between streams of cloud, sliding past on either side. This is the Great Red Spot. From Earth, the Great Red Spot often appears in photographs as a prominent red mark on Jupiter. Because of this, people may unconsciously imagine it as a feature on the surface, like a patch of paint, an impact crater, or a region of differently colored land. But as the spacecraft draws closer in our imagination, that idea must be left behind. The Great Red Spot is not a solid object. It is not a crater. It is not a red field or an exposed region of land beneath the clouds. It is an enormous storm within Jupiter's atmosphere, a vortex so large that if Earth were placed beside it, our home planet would appear small. The view from the window would not resemble looking down at a storm on Earth from an airplane. On our planet, hurricanes have spiraling clouds, an eye, rain, and an ocean below. Powerful as they may be, they still unfold within a relatively thin atmosphere above the surface of a rocky world. The Great Red Spot belongs to a different kind of planet. It exists within the deep atmosphere of a gas giant, where there is no solid ground for the storm to cross and gradually weaken, as many storms do on Earth. It is sustained within a system of powerful winds, between atmospheric currents that race around the planet, and within an environment operating on a scale far beyond anything in human experience of weather. If the spacecraft passed overhead, the Great Red Spot would not immediately appear as a perfect circle. At first, you would see an elongated red-orange region nestled between the surrounding cloud bands. Its edges would not be hard, like a line drawn with a pen. Because it is made of moving gas, its boundaries contain strands of stretched cloud, gentle bends, and smaller regions being drawn inward or pulled away. The colors within it are uneven. Some areas are lighter, others deeper, with cloud layers turning softly as though sliding around an invisible center. The entire structure resembles an immense vortex rotating slowly below you, although that slowness belongs only to the distant observer. In reality, the winds there are extraordinarily powerful. The Great Red Spot is an anticyclonic storm, meaning that it rotates around a region of high atmospheric pressure. This differs from the familiar image of many tropical storms on Earth, which are generally associated with low-pressure systems. On Jupiter, the storm lies between two powerful air currents moving in opposite directions. These currents are like enormous atmospheric rivers flowing around the planet, one to the north and one to the south, creating conditions that help contain the great vortex and allow it to endure. From the window, you would see that the Great Red Spot is not isolated. It is surrounded by cloud bands, wind currents, and smaller structures that continually interact with it. What makes the Great Red Spot remarkable is not only its size, but also its age. Storms on Earth can be extremely powerful, yet they usually survive for days, weeks, or periods far shorter than the span of human history. The Great Red Spot has been continuously observed for a very long time, across generations of telescopes, spacecraft, and scientists. It has appeared in early drawings, Voyager photographs, Hubble data, ground-based observations, and Juno's close passes. The thought that a storm could outlive many human lifetimes makes the scene beneath the window feel quieter and deeper. This is not a fleeting moment of weather. It is an atmospheric structure that has endured throughout much of humanity's history of observing Jupiter. Yet the Great Red Spot is not unchanging. This is an important scientific point. It is famous for its longevity, but that does not mean it has preserved the same shape forever. Observations show that its size has changed over time, with the storm shrinking compared with records from earlier centuries. It remains enormous, still wider than Earth, but it is no longer as large as it once appeared in historical observations. This makes it even more fascinating. A feature that seems like an eternal symbol of Jupiter is evolving as well. It has a history, it changes, and it still holds mysteries that human beings have not completely understood. From the perspective of someone flying past, those long-term changes would not be visible within a few minutes. You could not watch the Great Red Spot shrink before your eyes. It moves and rotates within the atmosphere, but changes in its overall size unfold across timescales far longer than a single flight. We know this because people have observed it patiently. Images, drawings, and measurements gathered over many years have been placed beside one another. In this way, a storm on a distant planet becomes a story with a timeline. This is another kind of beauty found in science. It does not observe only one moment, but preserves many moments, so that change can eventually be seen. The red color of the Great Red Spot is another compelling question. Why is it red? The answer is still not entirely simple. Scientists believe the color may be connected to chemical compounds in the atmosphere that are altered by sunlight and other processes, producing particles or substances with distinctive colors in the upper cloud layers. But the story cannot easily be reduced to a single cause. Jupiter has a complex atmosphere, and the color of a vast storm, like the Great Red Spot, may be influenced by chemical composition, cloud altitude, sunlight, temperature, and the way material is carried upward from deeper layers. So when we look at that red color, we are not merely seeing a shade. We are seeing an unanswered question. Looking more closely, you may notice smaller vortices and stretched cloud formations around the Great Red Spot. Some approach the edge of the storm, become elongated, and then slide around it, or are torn apart. The Great Storm behaves like something soft yet powerful. It has no solid surface and no walls, yet it can still organize the movement around it. Clouds passing nearby do not continue along ordinary straight paths. They are influenced by the enormous vortex, by powerful winds, and by the boundaries between atmospheric bands. From a distance, everything appears smooth and beautiful. In reality, it is a region filled with tremendous energy. When Juno passed close to Jupiter, scientists wanted more than photographs of the Great Red Spot from above. They wanted to know how deep it extends. Is a storm this large merely a thin pattern across the uppermost clouds, or does it have roots reaching farther into the atmosphere? Data from Juno indicate that the Great Red Spot is not simply a shallow feature. Its structure may extend hundreds of miles below the visible cloud tops. This makes the storm even more remarkable. What we see is only its upper face. Beneath that red region lies a deep atmospheric structure, where temperature, pressure, and motion change with depth. Imagine watching a whirlpool on the surface of water. From above, you see the spiral pattern, but the movement may continue downward through deeper layers. A similar idea can help us picture the Great Red Spot, even though the environment is entirely different. This is not water, but Jupiter's atmosphere. This is not a pond or an ocean on Earth, but an enormous gas giant. The vortex visible at the cloud tops is connected to deeper movements below, and that connection may help the storm endure far longer than a temporary streak of cloud. The view holds your attention because it brings together two opposing feelings. On one hand, the Great Red Spot is beautiful. Its colors are deep, its shape is distinct, and it stands out clearly against the bright and dark cloud bands surrounding it. On the other hand, that beauty comes from an environment that is anything but gentle. Powerful winds, a deep atmosphere, immense pressure, constant motion, interactions between jet streams, and chemical processes that are still not fully understood. It is like a silent painting created by force. And that is what makes Jupiter more than a beautiful scene. The more you understand it, the greater its weight becomes. Inside the spacecraft, You remain safe beside the imagined window. No sound from Jupiter's winds can reach you, because the space between the ship and the planet is a vacuum. There is no noise to tell you how enormous the storm truly is. Everything depends on sight and imagination. You look at a red oval resting between the cloud bands and remember that it is wider than Earth. You watch the storm's soft, curling edges and remember that this is not colored ink, but gas in rotation. It appears calm, yet you know it is one of the most famous storm systems in the solar system. The silence does not make the sight feel smaller. It gives it greater depth. The Great Red Spot also helps correct an important misunderstanding about weather. On Earth, we usually think of weather as something temporary, changing from one day to the next. The sky clears, rain falls, storms arrive, and then they fade. On Jupiter, some atmospheric structures can persist for an extraordinarily long time. This does not mean Jupiter's atmosphere is stable in the sense of being motionless. Quite the opposite, it is constantly moving, but that motion can organize itself into large patterns that endure far longer than anything familiar to us. The Great Red Spot is the clearest example, a storm that is not merely chaos, but a structure maintained by the atmospheric conditions surrounding it. As the spacecraft passes by, you might imagine yourself looking into a very different kind of clock. Not a clock with second, minute, and hour hands, but a clock made from a planetary atmosphere. Every rotation is a movement. Every change in size is a sign of time passing across longer scales. Every telescope measurement is another moment when human beings check to see how that clock has changed. Beneath it all, Jupiter continues to rotate rapidly, drawing its cloud bands around the planet, while the Great Red Spot drifts between powerful currents like an ancient whirlpool in a sea of gas. This is why the Great Red Spot should not be treated as a decorative detail. It is a window into the dynamics of Jupiter's atmosphere. It reveals how immense a storm on a gas giant can become. It raises questions about how deeply vortices extend. It connects to the planet's jet streams, internal heat, cloud chemistry, rapid rotation, and long history of astronomical observation. A red spot in a photograph becomes a meeting point for many branches of science: planetary meteorology, fluid physics, atmospheric chemistry, space observation, and computer modeling. But our journey does not need to turn this moment into a heavy lecture. We only need to let the listener understand what matters most. The Great Red Spot is a real storm, in a real atmosphere, on a real planet, yet its scale exceeds every storm familiar to us. It does not make Jupiter frightening in a loud or dramatic way. It makes the planet deeper, more dynamic, and more difficult to forget. When a world can sustain a storm for so long, we begin to understand that time on other planets may be written in enormous shapes. The spacecraft begins to pass beyond the clearest view of the Great Red Spot. Slowly, the storm drifts toward the rear of the window, and other cloud bands begin to fill your vision again. But after seeing it, you will never look at Jupiter in quite the same way. The bright and dark stripes are no longer merely a background. They are the environment that sustains vortices. The colored regions are no longer simply colors. They are signs of matter and motion. The red spot is no longer just a symbol. It is a storm, a record of time, and a scientific question that remains open. And as the red storm recedes behind us, the journey needs a slower rhythm. After witnessing something so immense, we should not rush immediately toward the next detail. Let your eyes rest upon the drifting cloud bands. Allow your body to relax inside the quiet cabin. Below, Jupiter continues to turn. The Great Red Spot continues to rotate. Powerful winds continue to race around the planet. And we, small observers passing above, have just traveled past one of the most famous storms humanity has ever known, continuing onward over a world of clouds with no solid ground. Chapter 8. A slow breath above the storms. As the Great Red Spot gradually drifts out of the window, the spacecraft does not immediately race toward another spectacle. It continues gliding above Jupiter's cloud bands, seeming to move more slowly now, as though the journey itself needs a moment to rest. Below, that immense storm is still turning within the atmosphere, still held between powerful currents, still forming a structure wider than Earth. But from your position, it has begun to fall behind, becoming a deep red region among bands of color curving around the planet. What you have just witnessed is too large to understand all at once. So instead of hurrying toward another discovery, We allow our eyes to rest on the clouds below, giving the imagination time to rearrange its sense of scale. Jupiter beneath us remains completely silent. There is no roar of the storm against the window, no thunder rising from the cloud layers, and no wind striking the spacecraft. In space, sound cannot travel as it does through Earth's atmosphere. The cabin remains quiet, filled only with the low background hum of the instruments and the gentle light of the control panel. Outside, an enormous planet moves without making any sound for the observer. That silence makes the view feel even stranger. On Earth, we usually associate storms with noise, heavy rain, powerful winds, trembling windows, thunder, and rough seas. Here, a storm larger than our home planet can appear in complete silence, like a deep image resting at the bottom of the universe. After seeing something like the Great Red Spot, it is important to remember one fundamental truth. Nothing before you is solid ground. The bright and dark regions, cloud lines, smaller vortices, and colored bands stretching around the planet all belong to the atmosphere. When we look down at Earth from orbit, we can distinguish clouds from the surface below. In some places, clouds cover the ocean. Elsewhere, openings reveal continents, while fixed white ice remains at the poles. But on Jupiter, no familiar surface appears beneath the clouds. There are no coastlines marking boundaries. There are no mountains from which anyone could look down upon a storm. There is no ground for rain to reach before its journey ends. The planet appears before us as a world of gas, where the visible layer is only the uppermost part of a much deeper system. This makes every cloud band more meaningful. If these patterns belong to a solid surface, we might think of them as fixed regions, like colors on a map. But because they are part of the atmosphere, every line is a form of motion. A bright region is not merely a bright color. It may be a place where clouds rise higher and reflect more sunlight, or where material is being carried upward from deeper below. A dark region is not rock or soil beneath the clouds, but perhaps a place where the upper cloud layers are thinner, allowing us to see farther into the atmosphere. A rippling boundary between two colored bands is not a territorial border. It is a place where different currents of gas slide past one another, pulling, twisting, and creating complex cloud structures. As the spacecraft glides onward, you may imagine yourself flying above an ocean, though this ocean contains no water. It is an ocean of atmosphere. Its currents do not strike coastlines, flow into rivers, or break against sandy shores. They circle the entire planet, stretched into nearly parallel bands by Jupiter's rapid rotation. Some currents look smooth and even, almost as though they have been carefully brushed into place. Other regions are more tangled, broken by smaller vortices, cloud waves, and patches of color curling into one another. Seen from far away, it all resembles a motionless painting, but with even a little understanding, you know that it is a picture continuously being painted by wind. In this quieter moment, we do not need more numbers. There is no need to measure wind speeds, the depth of the storms, or the composition of every cloud layer just yet. We only need to hold on to what we have already learned. Jupiter is a gas giant. Its stripes are the visible motion of its atmosphere. The Great Red Spot is a storm, not a mark upon solid ground. Its clouds are unlike those on Earth because they form from different compounds within an atmosphere made primarily of hydrogen and helium. And the entire world beneath the window is not a place where we could land, but a place to observe, measure, and learn humility before something so immense. There is a very particular feeling that comes from looking at a planet where human beings could never stand. Earth gives us ground beneath our feet, sky above us, and a horizon in the distance. Even when standing before a vast ocean or a towering mountain, the human body still understands where it is. Jupiter offers no such sense of orientation. If we imagine descending beneath the clouds, we do not find a clearly defined floor. We encounter only greater pressure, rising temperatures, denser gases, and increasingly hostile conditions. Looking at Jupiter from the outside is therefore like standing before a door that cannot be opened by the body, but only through science. We cannot enter it in the ordinary way. Instead, we send probes, use cameras, spectroscopy, microwaves, infrared instruments, magnetometers, and models, then bring each fragment of data together to understand a world no human foot could ever touch. This does not make the planet feel more distant. On the contrary, it makes every observation more precious. Each image of Jupiter is a way of drawing closer without needing to land. Every cloud band is a question. Every storm is a lesson about atmospheres. Every region of color offers a clue about matter and altitude. Whenever a spacecraft passes nearby, humanity receives another small cross-section of the truth. We do not understand Jupiter by claiming it. We understand it by observing carefully, accepting our limitations, and allowing the data to speak slowly across many years. Below the spacecraft, the cloud bands continue to drift. One bright region stretches out like white mist. Beside it lies a reddish-brown band, deeper and heavier in color. Between them, thin strands of cloud are drawn out along the wind. In some places, they twist into small loops before quickly dissolving into the larger current. You might choose one small point in the atmosphere, watch it for a few seconds, and imagine it changing shape as the planet turns. But at their true scale, all these movements are far larger than they appear. A cloud streak that seems small to the human eye may extend across a distance greater than many countries. A tiny vortex in an image may be an enormous weather system when placed beside a map of Earth. Here, the feeling of being small does not need to be emphasized. It arises naturally. Simply, by looking at Jupiter, we understand that the human body is not the only measure of the universe. A day on Earth contains morning, afternoon, meals, work, and sleep. A day on Jupiter is much shorter, yet it unfolds across a vastly larger planet. Those cloud bands pass through days and nights of their own. One side of the planet is illuminated by the sun, while another quietly enters darkness. The red storm continues to turn. The jet streams continue sliding past one another. No one stands below to name each cloud, yet physics continues its work. Within this slower rhythm, we can also look at Jupiter with a gentler feeling. It is not only a violent planet, it is also a planet of rhythms. The rhythm of its rapid rotation creates the bands. The rhythm of convection carries material upward and downward. The rhythm of the winds holds storms within certain regions. The rhythm of light causes colors to brighten and fade as the planet moves through day and night. Even the great red spot, powerful as it is, does not appear like a sudden explosion. It is a persistent structure, sustained by the conditions of the planet. Jupiter's violence is not loud to the distant observer. It can be very slow, very broad, and very deep. If a small screen inside the cabin displayed our position, you would see the spacecraft as little more than a tiny point beside an enormous planet. But through the window, no screen is needed to understand that. Jupiter fills your field of view. The longer you look, the more difficult it becomes to contain the planet within a single description. It is not merely the largest planet. It is not only the planet with the great red spot. It is not simply a ball of gas. It is a deep atmospheric system with multiple cloud layers, long-lived storms, powerful winds, a vast magnetic field, a rich family of moons, and mysteries that remain unresolved. But in this moment, we do not need to explore every mystery. We simply remain with the clouds below, like someone standing quietly beside a wide river. Perhaps this is the part of the journey that comes closest to sleep. Not because the science has disappeared, but because it has settled into a slower rhythm of breathing. We are not trying to crowd in more information. We are allowing what we have just learned to sink in. Jupiter's clouds are unlike the clouds of Earth. The great red spot is a storm. The bright and dark stripes are a flowing atmosphere. This planet has no surface where a spacecraft could land. These ideas alone are enough to transform the view completely. An image that once seemed familiar becomes deeper, and that depth holds our attention not through drama, but through the quiet desire to understand more. The spacecraft continues across the sunlit side of the planet. Along the distant edge, darkness begins to swallow the cloud bands. Whites, browns, and oranges fade along Jupiter's curve before disappearing into night. The side illuminated by the sun remains more clearly defined, but even the dark side does not vanish completely from the imagination. You know that beneath that darkness, the winds are still moving. The storm is still turning. Cloud layers continue to form and dissolve. Jupiter does not need to be fully visible in order to continue existing. It keeps rotating through darkness, as every planet does. Then, as your attention slowly moves away from the storms, another detail begins to prepare its entrance. It does not come from Jupiter's atmosphere itself, but from the smaller worlds orbiting around it. Somewhere ahead, a moon will pass between the sun and the cloud tops of the giant planet. When that happens, a small, round, dark shadow will glide across the bright bands below. After the immensity of the storms, the sight will feel gentler and smaller, yet no less strange. It reminds us that Jupiter is more than an atmosphere. It has a family of moons moving around it, and sometimes those moons write their shadows across the planet's cloud-covered face. So let the rhythm remain slow for a little longer. Allow the great red spot to drift farther behind us. Let the cloud bands return to being a soft background beneath the window. We have just passed an ancient storm, but the journey around Jupiter still holds many other sights. Ahead, there is no new storm, but a quiet circular shadow preparing to cross the clouds. A small moon, unimaginably distant from the scale of the human body, will create something like an eclipse on a world where no one stands below to watch it, and our spacecraft will continue silently onward, above a giant planet breathing through wind, clouds, and time. After the spacecraft has glided past Jupiter's storms and vast cloud bands, the next sight arrives quietly. It does not have the deep red color of the great red spot, the immense spiraling patterns, or the complex cloud structures stretching around the planet. At first, you notice only a very small area of the bright cloud tops growing slightly darker. Then that darkness becomes clearer, forming a round, black spot, more sharply defined than the cloud patterns around it. It is not stretched out like the belts and zones. It does not swirl like a storm. It moves silently across Jupiter's cloud-covered face, like a black dot placed upon a painting in motion. It may be the shadow of a moon. Seen from far away, that dark point could easily be misunderstood. Someone unfamiliar with the sight might imagine it to be a small storm, a deep opening in the clouds, a darker region of the atmosphere, or an unusual mark on Jupiter. But it does not belong to the atmosphere. It is not created by clouds, wind, or chemistry. It is a shadow. One of Jupiter's moons is passing between the sun and the planet's cloud tops. The moon blocks the sunlight, and the clouds below fall into darkness for a short time. In other words, this is a kind of solar eclipse, but it is not taking place on Earth. It is happening across the clouds of a giant gas planet. On Earth, when the moon passes between us and the sun, its shadow may sweep across the planet's surface and create a solar eclipse. Anyone standing within the shadow can see the sun partly or completely covered. But on Jupiter, there are no people standing on solid ground and looking upward. No cities grow dark in the middle of the day. No birds fall silent, no streets dim, and no ocean surface reflects the weakening light. There are only layers of cloud. So, instead of imagining an observer standing below, we watch from outside as a circular shadow glides across the atmosphere, like a geometric mark written upon the clouds. The sight is gentle, but its scientific meaning is profound. It shows that Jupiter's moons are not merely points of light near the planet. They are real celestial bodies with size, orbits, and changing positions relative to the Sun and Jupiter. When a moon passes directly between the Sun and Jupiter, it casts a shadow. That shadow is visible evidence of orbital motion. You do not need to hear an instrument or see an orbit traced across a screen. You can understand that a world is moving through space, and its movement is changing the light falling upon the giant planet. The 4 Galilean moons Io, Europa, Ganymede, and Callisto are the largest worlds in the Jovian system, and each can cast shadows when the geometry is right. Depending on the size, distance, and position of the moon, those shadows may look different. Some are smaller, while others are larger. Some appear especially dark and distinct, while others seem to cross the planet more quickly or slowly from the observer's point of view. Io orbits closer to Jupiter, so it travels around the planet more rapidly. Ganymede is much larger, but also farther away. Europa is bright and covered in ice, while Callisto travels farther out still. Each moon has its own orbit and character, but whenever its shadow falls across Jupiter's clouds, it reminds us of the same thing. This planet is surrounded by an entire system in motion. From the spacecraft window, the moon's shadow may look strange because it is so clearly defined compared with the clouds around it. Jupiter's cloud bands are usually soft, their edges stretched, blended, and curved by the winds. The shadow of a moon appears rounder, darker, and more geometric. It is not part of the atmospheric flow, so it does not immediately twist or curl with the clouds. It is projected onto them from outside. When the shadow crosses a bright band, It resembles a drop of black ink moving over a creamy white background. When it passes across a darker belt, it may be harder to see, but it still retains its distinct nature, a region darkened by blocked sunlight, not by the composition of the clouds. What makes the sight even more interesting is that the shadow is not moving across a fixed surface. It is sliding over a rapidly rotating planet, across cloud layers that are also in motion. The scene is therefore a combination of several movements happening at once. The Moon is orbiting Jupiter. Jupiter is rotating on its axis. The atmospheric bands are flowing within different wind currents. Sunlight is arriving from one direction, and our spacecraft is moving through the space near the planet. A small black dot on the clouds may look simple, but behind it lies an intricate pattern of motion. You might imagine the Moon's shadow as the shadow of a leaf passing across a table while sunlight enters through a window. As the leaf moves gently through the light, its shadow glides over the surface below. But at Jupiter, the leaf is a large moon, the table is the cloud layer of an enormous gas planet, and the light comes from the distant Sunday. The comparison makes the sight feel more familiar, while also revealing its extraordinary scale. A simple experience from everyday life, an object blocking light and casting a shadow, has been enlarged into an astronomical event on a giant world. These shadows also allow us to experience Jupiter through time, not only through color. A storm may endure for years, a cloud band may stretch around the entire planet, but a moon's shadow is a passing moment. It appears, moves, and disappears. Once the moon leaves the line between the sun and Jupiter, the shadow is like the slow hand of a clock moving across the clouds. It tells us that orbital motion is taking place. It shows that the moons are not simply there. They are continually traveling through new positions in space. Throughout the history of astronomy, observations of Jupiter's moons have carried enormous importance. When Galileo watched the small points of light changing position around Jupiter from night to night, he realized that not everything in the sky revolved around Earth. Those moons were orbiting Jupiter. It was a profound change in the way human beings understood their place in the universe. Today, when we watch the shadows of those moons move across Jupiter's clouds, we are seeing a more visual expression of the same idea. Worlds can orbit other worlds, and their movement can be read through light. From the surface of Earth, amateur astronomers with sufficiently powerful telescopes can sometimes observe the shadows of Jupiter's moons. A small black dot moves across the planet's disk, while the moon itself may appear as a bright point or become difficult to see, depending on its position and the surrounding contrast. In images taken by spacecraft, the scene is much clearer. We can see the shadow resting on Jupiter's cloud bands, sometimes so sharply defined that it almost seems not to belong to the planet at all. Yet that very strangeness makes it a beautiful piece of evidence: light, matter, and orbit meeting in exactly the right place. If the shadow belongs to Io, the volcanic moon orbiting close to Jupiter, it may cross the planet relatively quickly compared with the shadows of more distant moons. Io travels around Jupiter in a short orbit, experiences powerful tidal forces, and later in our journey will appear as a hot and violently active world. Yet Io's shadow on Jupiter's clouds is completely silent. It reveals nothing of the volcanoes or the yellow-orange surface. It is only a small circle of darkness, but that circle tells us that Io is positioned directly between the sun and the giant planet. If the shadow belongs to Europa, the feeling is different in the imagination. Europa is an icy moon, a world that has drawn great interest because it may contain an ocean beneath its frozen crust. As its shadow moves across Jupiter, we cannot see that hidden ocean. We see only a circular mark upon the clouds. Yet that mark connects a small frozen world to the enormous gas planet below. Europa is not merely a distant object near the edge of the scene. It is taking part in the dance of light within the Jovian system. Ganymede, the largest moon in the solar system, can also cast a striking shadow. Its size makes the idea of Jupiter as a miniature solar system feel even more vivid. A moon larger than Mercury is orbiting an enormous gas giant, and its shadow can fall across cloud layers that extend thousands of miles into the atmosphere. Callisto orbits farther away and has a surface that appears far more ancient, while its shadow transits depend on its orbital position and the angle of the sunlight. Each moon has a rhythm of its own, but from the spacecraft, we may see only something very simple: a dark circle passing through the light. There is a quiet beauty in this sight. After the storms of Jupiter, a moon's shadow does not need to overwhelm us with its size. It holds our attention through precision. It reminds us that the universe contains not only power, but geometry. A moon crosses an imaginary line. Sunlight is blocked. A shadow falls upon the clouds. The planet continues to rotate. Everything follows clear physical laws, without noise or display. A single black dot is enough to reveal the order within celestial motion. And because Jupiter rotates so quickly, the shadow does not move across a fixed background. As it travels, the cloud bands below are also flowing with the atmosphere. The view is therefore one layer of motion passing over another. The shadow belongs to the moon and the light. The clouds belong to Jupiter's atmosphere. One is created by orbital geometry, the other by atmospheric dynamics. They meet for a few hours, forming an image the human eye can recognize immediately, yet one that science can explain in far greater depth. If you look carefully at the shadow's edge, you might imagine that it is not a perfectly cut circle. The sun has an apparent size in the sky. The moon has a real three-dimensional shape. The cloud tops rise to different altitudes, and the observer's position also affects the way the shadow appears. But compared with the soft, tangled patterns of Jupiter's clouds, a moon's shadow still looks much cleaner and more orderly. That neatness makes it stand out. It is like a punctuation mark in the very long sentence of Jupiter's atmosphere. As the shadow crosses a bright region, the giant planet may suddenly feel almost familiar. No matter how different Jupiter is from Earth, the principle remains the same. An object blocking light creates a shadow. A child on Earth can understand this by holding a hand in front of a lamp and watching its shadow appear on the wall. Here, the hand is a moon, the wall is Jupiter's cloud layer, and the lamp is the Sunday. Science sometimes begins with something as ordinary as this, then expands it into scales that everyday life could never contain. The moon's shadow also reminds us that Jupiter can be viewed from more than one perspective. If someone could stand, or more accurately, somehow remain suspended within Jupiter's atmosphere, the event would look different. An imaginary observer beneath the shadow might see the sun obscured by the moon, creating an eclipse in Jupiter's sky. But because Jupiter has no solid surface where anyone could stand, that view belongs only to the imagination. The safer and more scientific perspective is from outside, a silent shadow traveling across the cloud tops. That view is enough to understand the event without placing human beings in an environment where they could never survive. As the spacecraft continues to drift, the circular shadow gradually leaves the bright region. It crosses the boundary between cloud bands, passes over a white zone, and then reaches a darker belt. At times it appears sharply defined. At others, it blends slightly into the darker background, before becoming distinct again over another bright region. Eventually, as the moon continues along its orbit and the angle of illumination changes, the shadow leaves the disk of the planet. Jupiter returns to its familiar bands, vortices, and storms. But after seeing that shadow, you no longer look at the bright points surrounding Jupiter in quite the same way. They are not merely decorations around the planet. They are worlds capable of blocking the light of the Sunday. This is a gentle transition in our journey. At first, we saw Jupiter as a planet. Then we explored its atmosphere, its cloud bands, chemical layers, and great red storm. Now we are beginning to see Jupiter as the center of a system. Its moons are no longer outside the story. They enter the scene through their own shadows. And as we turn toward those moons in the chapters ahead, we will discover that they are nothing alike. One may be filled with volcanoes. Another may conceal an ocean beneath its ice. One is larger than a small planet. Another preserves ancient scars from the early solar system across its surface. But before we leave the circular shadow gliding across the clouds, let the moment remain for one more breath. A giant planet is turning. A much smaller moon is passing in front of the Sunday. A region of cloud falls into darkness. A spacecraft watches silently from far away. There is no sound, no announcement, and no need to hurry. There is only geometry, light, and motion, written as a black dot across Jupiter's cloud tops. And sometimes, in the universe, a small point of darkness is enough to remind us that every world is moving within relationships larger than itself. After the quiet circular shadow passes across Jupiter's cloud tops, our attention moves away from the central planet and turns toward a nearby point of light. It is far smaller, less overwhelming, but not peaceful at all. This is Io. Seen only from a distance, Io could easily be mistaken for an ordinary satellite, a tiny point of light beside Jupiter's enormous sphere. But as the distance narrows, the moon begins to reveal a very different appearance. It is not cold and gray like Earth's moon. It is not pale blue and white like a frozen world. Io's surface carries shades of yellow, orange, white, deep red, and dark gray, as though it has been covered in sulfur, volcanic ash, and layers of material continually erupted from within. It does not look ancient or still. It resembles a map being rewritten too quickly for the older markings to remain undisturbed. Io is the most volcanically active body in the solar system, not merely the most active moon, and not only the most dramatic world around Jupiter, but the most volcanically active place we know anywhere in the solar system. Hundreds of volcanoes cover its surface. Some eruptions can send material tens or even hundreds of miles above the ground before dust, gas, and sulfur compounds fall back to the surface. From far away, these plumes may look as delicate as thin umbrellas, opening into the darkness. But their true nature is one of heat, pressure, gas, molten rock, and material driven outward from an interior that never truly rests. The important question is, why can such a small moon, so far from the sun, be so violent? The answer does not lie in sunlight. Io is not hot because it is close to the Sunday. It orbits in the outer solar system, where sunlight is much weaker than it is on Earth. The main source of energy driving Io's activity is tidal force, or more simply, the constant stretching caused by gravity. Jupiter is enormous. Its gravity is so powerful that Io does not simply travel around the planet in a calm, undisturbed orbit. Throughout each orbit, Io is pulled, compressed, and gently flexed in rhythm with its motion. If Io's orbit were perfectly circular and unaffected by the other moons, this stretching might be more constant. But Europa and Ganymede also influence Io through a pattern known as orbital resonance. Their small but regular gravitational pulls keep Io's orbit slightly elliptical. As its distance from Jupiter changes during each orbit, the amount of internal stretching changes as well. One familiar way to imagine this is to take a thin piece of metal and bend it back and forth repeatedly. After a while, the bent area begins to warm. On Io, gravity does something similar on the scale of an entire celestial body. It does not bend the moon the way a hand bends a wire, but it repeatedly deforms Io's interior. Friction and movement inside the moon generate heat. That heat partially melts material beneath the crust, creating magma, pressure, and pathways toward the surface. As a result, Io does not merely have a few scattered volcanoes. The entire moon is almost one vast volcanic system, kept active by Jupiter's influence. Looking at Io, we can see a powerful scientific lesson. A world does not need to be close to the sun to have internal energy. Sunlight is not the only source of heat in the solar system. Gravity can also warm a celestial body if it pulls strongly enough, for long enough, and without rest. On Io, gravity does more than maintain an orbit. It reshapes the moon from within. Io's surface reflects this very clearly. Its yellow and orange regions are largely connected to sulfur and sulfur compounds. Darker patches may be newer volcanic material, where lava or heated matter has spread across the surface. Bright rings, colored halos, and stains surrounding volcanic vents show where material was once blasted upward and then fell back down, coating the ground like natural paint. On many other rocky worlds, impact craters can remain visible for a very long time because the surface changes so little. On Io, volcanic activity continually resurfaces the landscape, covering many older features. Io is not like an ancient book gathering dust. It is more like a page being written over again and again. The atmosphere around Io is extremely thin and consists mainly of sulfur dioxide, a gas connected to volcanic activity and to material on the surface freezing and then turning directly back into gas. It is not a thick atmosphere capable of producing clouds, rain, or a sky like Earth's. If Earth's atmosphere is a protective blanket, Io's atmosphere is only a very thin covering, changing with activity on the surface and with its interactions with the environment around Jupiter. Because of this, when we observe Io, we are looking almost directly at a volcanic surface that is constantly being renewed. Io's harshness comes not only from its volcanoes, but also from its location. It orbits close to Jupiter, deep within an environment of powerful magnetic fields and intense radiation. Material from volcanic eruptions can escape the moon, become electrically charged, and then be swept into Jupiter's magnetic field. Over time, Io helps create a region of plasma along its orbit. In other words, Io is not only shaped by Jupiter, it also contributes material to the environment surrounding its parent planet. Through its volcanic activity, a small moon becomes part of a much larger system. This is what makes Io so remarkable. It is not a secondary object placed beside Jupiter merely to complete the scene. It is an active link in the system. Jupiter pulls on Io. Europa and Ganymede help preserve the orbital rhythm that keeps Io flexing. Io's interior heats up. Volcanoes erupt. Material falls back onto the surface or escapes into space. Jupiter's magnetic field captures those particles. Together, these events form a connected chain. Orbit, gravity, heat, volcanoes, plasma, and magnetism. This is a beautiful kind of science because it shows that celestial bodies do not exist in isolation. A moon can be shaped by its parent planet. A planet's surrounding environment can be changed by one of its moons. Objects that appear separate in photographs are actually exchanging energy and matter. The Jovian system is therefore more than a large planet with a few small points traveling around it. It resembles a natural machine in which every part affects the others. If we place Io beside Earth in our imagination, the differences become clear. Earth has volcanoes, but they exist within a world of plate tectonics, oceans, a thick atmosphere, water, and life. Io's volcanoes belong to a very different setting: drier, more exposed, more continuous, and driven by tidal heating rather than by plate tectonics like those on Earth. There are no forests growing near volcanic slopes. No oceans receive the lava. No rain cools the ash. There is only a surface repeatedly covered by sulfur, lava, gas, and erupted material. For this reason, Io is not an obvious place to consider when thinking about life. It is too extreme, too volcanically active, and too close to Jupiter's intense radiation environment. Yet Io is extraordinarily important for understanding how worlds function. It shows us that geology is not limited to large planets. A moon can also have a dynamic history. A small celestial body can retain heat if gravity stirs its interior strongly enough. And in the outer solar system, where sunlight becomes weak, internal energy sources such as tidal heating can become decisive. This will become even more important in the next chapter. Io is the most dramatic example of tidal heating, where that energy erupts through volcanoes. But on other moons, the same basic influence of tidal forces can lead to very different outcomes. Europa does not display volcanic activity as prominently as Io, yet it may preserve an ocean beneath its icy crust. Ganymede is enormous and has a magnetic field of its own. Callisto appears colder and older, preserving more ancient impact scars across its surface. In other words, Jupiter's gravity does not create only one kind of world. It helps shape many very different destinies. As Io drifts away from the center of the view, we can hold on to one clear image: a small, yellow, orange moon near the largest planet in the solar system, stretched from within, covered in volcanoes, and continually renewing its own surface. It is not peaceful simply because it appears distant. It is not frozen into death merely because it lies far from the sunday. It is active, losing material, interacting with Jupiter's magnetic field, and showing us the quiet power of gravity. Jupiter teaches us about clouds, storms, and atmospheres. Io offers a different lesson. Sometimes, what makes a world dynamic is not sunlight, but the unending pull of another world nearby. In the darkness, far from the sun, a moon can still burn from within. Io's intense yellow-orange colors do not remain at the center of our journey through the Jovian system forever. Farther out, the Galilean moons begin to speak in a different tone. Fire gives way to ice. The vivid sulfur-covered terrain is replaced by gray-white surfaces, delicate fractures, overlapping impact craters, and layers of frozen material that have remained there for immense stretches of time. If Io is a moon continually rewriting itself through volcanic activity, then Europa, Ganymede, and Callisto tell their stories more slowly. They do not erupt violently before our eyes, yet each one holds a profound question beneath its quiet exterior. Europa is the first to draw our attention toward ice. From a distance, it appears small and bright, less impressive in size than Ganymede, and far less dramatic than Io. But the longer you look, the stranger its surface becomes. Long reddish-brown lines cross the white ice, intersecting in wide networks like fractures across an old pane of glass. There are no easily recognizable mountain ranges, no open seas reflecting the light, no clouds or thick atmosphere hiding the surface. Europa presents an almost bare and frozen exterior, and it is precisely this cold emptiness that has captured the attention of science. The question lies beneath the ice. Does Europa contain a global ocean of salty liquid water? This is not merely an imaginative idea added to the story. Observations, especially data gathered by the Galileo spacecraft, have revealed signs consistent with a layer of electrically conductive liquid beneath the surface. Within Jupiter's powerful magnetic environment, a salty ocean could produce an induced magnetic signal. Put more simply, Europa moves through the magnetic field of its parent planet, and the way it responds suggests that liquid water containing dissolved salts may exist beneath its icy crust. We cannot see that ocean directly. There are no visible waves, no shorelines, and none of the familiar blue color of Earth's seas. There is only ice, a network of fractures, and subtle signals that scientific instruments must read with great care. It is important to be clear that life has not been discovered on Europa. Science does not make that claim. What makes the moon important is the possibility that it may possess several conditions worth investigating: liquid water, sources of energy, and chemical ingredients capable of supporting complex reactions. Europa's surface is extremely cold and lies within Jupiter's intense radiation environment. If there is a more promising place to explore, it would not be on the exposed ice, but deep below it, where a dark ocean may be shielded from the space outside. Europa is therefore not a smaller version of Earth. It asks a different question. Can a world without warm sunlight at its surface still preserve an environment worth studying within? From Io to Europa, the same gravitational influence from Jupiter produces two very different results. On Io, tidal forces become intense heat, volcanoes, and a surface that is constantly renewed. On Europa, that same gravitational pull may help keep part of the interior warm enough to prevent all its water from freezing solid. One moon answers with fire, the other answers with fractured ice and a hidden ocean. This contrast makes the Jovian system far richer than a single planet, with a few satellites moving around it. It resembles a natural laboratory where the same physical force can help shape very different planetary destinies. Ganymede carries the story in another direction: scale. It is the largest moon in the solar system, even larger in diameter than Mercury. But Ganymede is more than simply large. Its surface contains older, darker regions, brighter areas crossed by long grooves, and signs that its crust was once deformed and reshaped. It does not possess Io's burning intensity, nor does its fractured ice immediately create the same curiosity as Europa's. Ganymede's appeal lies in its combination of size, internal structure, and one very unusual feature: a magnetic field of its own. Among all known moons, Ganymede is exceptional because it has an intrinsic magnetic field. This is a feature more commonly associated with planets than with natural satellites. Earth has a magnetic field because electrically conductive material moves within its interior, producing what scientists call a dynamo. In Ganymede's case, the existence of its own magnetic field suggests that the moon's interior is far more complex than its cold and quiet exterior might imply. Imagine an enormous moon orbiting Jupiter while carrying a small magnetic region of its own, enclosed within the much larger magnetosphere of its parent planet. It is one invisible sphere of influence nested inside another, much greater one. Human eyes cannot see this directly, but instruments designed to measure magnetic fields can detect it. Ganymede may also contain liquid water beneath its surface, although its story is not the same as Europa's. Its interior may contain several layers of ice and water under different pressures. If an ocean is present, it may lie much deeper, trapped between layers of ice, and whether it comes into contact with the rocky material below is an important question. When considering habitability, liquid water is only one part of the picture. Energy, chemistry, and an environment where those ingredients can interact are also needed. So Ganymede asks more than simply, is there water? It also asks, within what kind of structure does that water exist, and is it isolated or connected to the deeper interior? Callisto enters the story with a quieter rhythm. It orbits farther from Jupiter than the other 3 large Galilean moons, experiences weaker tidal effects, and has a surface densely covered in impact craters. If Io is a place where volcanic activity erases older markings, Callisto is a world where many of those markings have been preserved. Large and small circles overlap across its surface. Bright and dark regions bear the scars of impacts, and ancient craters give the moon the feeling of an archive. Callisto tells its story not through intense activity, but through preservation. An impact crater is more than a depression in the ground. It is evidence of an object that once traveled through space and struck the surface with enormous energy. A heavily cratered landscape records a long history of collisions. On more active worlds, volcanoes, tectonic changes, or moving ice may erase or soften those ancient marks. Callisto's surface has been renewed far less, allowing it to preserve many scars from the distant past. Because of this, it helps scientists study the history of impacts in the outer solar system during its earliest eras. Callisto may also have liquid water beneath its surface, although it is generally considered less active than Europa. If an ocean exists there, it may be colder, deeper, and supplied with less energy. For that reason, Callisto does not create the same sense of urgency as Europa in discussions about possible life. Yet this does not make it less valuable. A quiet world can be extremely important when it preserves history. Within the Jovian system, Callisto resembles an old record, less active, less dramatic, but filled with traces that more dynamic worlds have lost. Placed side by side, Europa, Ganymede, and Callisto make it clear why the 4 Galilean moons cannot be treated as identical points of light. Europa has a fractured icy crust and may conceal a salty ocean. Ganymede has extraordinary size, its own magnetic field, and a complex internal structure. Callisto preserves an ancient, heavily cratered surface like a record of impacts in time. They all orbit Jupiter and exist within the influence of the largest planet in the solar system. Yet each has developed its own way of being a world. Jupiter, then, is immense not only because of its diameter or mass, but because of the reach of its influence. Its gravity organizes the orbits around it. Its magnetic field surrounds the environment of its moons. Its radiation makes the nearby region of space intensely hostile. Its enduring presence has helped shape the heat, icy crusts, internal activity, and even the ability of its largest moons to preserve hidden oceans. When we look at these satellites, we do not separate them from Jupiter. We see them as different responses to the same enormous center of gravity. This is also why a journey past Jupiter should not end with its clouds and storms. If we look only at the planet, we see the great red spot, the belts and zones, and its many layered atmosphere. But when we turn our attention toward the moons, the Jovian system becomes a small model of planetary diversity. There are volcanoes, ice, possible oceans, a moon with its own magnetic field, ancient surfaces, and interconnected orbits. A region of space that seems to revolve around a single planet contains many worlds, each with a very different history. There is no need to make any of this overly mysterious. The truth is already vast enough. An ice-covered moon may conceal a dark ocean. A moon larger than Mercury possesses a magnetic field of its own. Another, farther away, preserves impact craters as traces of billions of years. These details are not loud or dramatic, yet they deepen the solar system within the imagination. Jupiter is no longer a solitary striped sphere suspended in darkness. It is the center of a family of celestial bodies, each carrying a different kind of memory. At the end of this part of our observation, 3 names remain, each with its own feeling. Europa, fractured ice and a possible ocean hidden far below. Ganymede, immense size, a magnetic field, and a complex layered interior. Callisto, an ancient, heavily cratered surface, preserving history in silence. Together with Io, they make the space surrounding Jupiter one of the richest sources of unanswered questions in the solar system. Between the planet and these moons, another structure is waiting to be seen, though it is extremely faint. It is not radiant like Saturn's rings, prominent like the Great Red Spot, or a world with its own surface like Europa or Ganymede. It is Jupiter's thin ring of dust, a layer of material almost hidden in darkness, visible only when the light passes through it at the right angle. Next our journey will narrow its focus, moving from the great moons to the quiet grains of dust, orbiting the largest planet in the solar system. Not everything surrounding Jupiter draws attention at first glance. Some structures are vast enough to fill the view, like the cloud bands and the Great Red Spot. Some are worlds in their own right, like Io, Europa, Ganymede, and Callisto. But there are also things that almost disappear into the darkness, so faint that if the light does not strike them from the right direction, we may never notice they are there at all. This is Jupiter's ring system. When we think of planetary rings, most of us immediately picture Saturn. The image of Saturn surrounded by broad, bright, beautiful rings has become one of the great symbols of the solar system. Because of this, it is easy to forget that Jupiter has rings as well, but Jupiter's rings are nothing like Saturn's. They are not brilliant, broad, or immediately visible as a great disk around the planet. They are far fainter, much darker, and composed mainly of tiny particles of dust. Viewed from the wrong angle, the entire ring system nearly disappears into the blackness of space. This makes Jupiter even more interesting. A planet already famous for its size, atmosphere, storms, and moons also possesses a delicate structure that the human eye can easily miss. Not every secret in the universe is found in a spectacular sight. Sometimes, a faint layer of dust can tell a long story about collisions, gravity, and the movement of matter around a planet. Jupiter's rings were discovered relatively late compared with the planet itself. Human beings have known Jupiter since ancient times because it is visible to the naked eye in the night sky. The Galilean moons were discovered in the early 17th century. The Great Red Spot has also been observed for many generations. But Jupiter's rings are too faint to be easily detected with ordinary telescopes from Earth. It was only when spacecraft flew past the planet and observed it from more favorable angles that this thin ring system was clearly confirmed. The reason is simple. Dust does not reflect light as strongly as the large pieces of ice found in Saturn's rings. The tiny particles around Jupiter absorb and scatter light in subtler ways. The rings become easier to see when sunlight shines from behind them or passes through at the right angle, much like dust in a dark room becoming visible only when a narrow beam of sunlight crosses it. Most of the time, the space around the planet appears empty, but from the right perspective, that emptiness suddenly reveals a thin, delicate layer of material, almost transparent. If we imagine the scene calmly, we do not see a radiant ring system like the familiar paintings of Saturn. We see something faint, like a very fine veil of smoke surrounding Jupiter. It does not dominate the view. It does not compete with the larger moons, nor does it make the planet more dramatic through brilliant color. It simply remains there, extremely thin and quiet, like the nearly erased outline of a small system of matter orbiting a giant world. The origin of Jupiter's rings is closely connected to dust from the small inner moons. These moons orbit close to Jupiter and can be struck by tiny meteoroids. Each impact may blast dust away from their surfaces. Because Jupiter's gravity is so powerful, those particles do not simply disappear. Some remain in orbit around the planet, gradually forming faint rings and dusty layers. In other words, Jupiter's rings are not separate from its system of moons. They are continually supplied by small impacts on the minor worlds orbiting nearby. This is an important scientific detail. A planetary ring does not have to be made from large, bright pieces of ice. It may consist almost entirely of very fine dust, and that dust may be produced by small events repeated over long periods of time. A tiny rock strikes a moon, material is thrown into space, new particles enter orbit, and sunlight, magnetic forces, and gravity gradually alter their paths. Through countless events like these, a faint structure takes shape around the planet. Jupiter's ring system is usually described as having several main parts. There is a main ring that is somewhat easier to detect, though still extremely faint compared with Saturn's. Closer to the planet lies a halo, a broader region of dust extending farther above and below the ring plane. Beyond that are the very thin gossamer rings, associated with small moons, such as Amalthea and Thebe. The word gossamer suggests something light and delicate, like fine silk, and that is a fitting way to imagine them. These rings do not resemble a solid structure. They are more like extremely fine dust spread across space. Even if we could approach them in imagination, we would not see the particles packed together into a dense wall. Planetary rings are actually very sparse. The distances between particles may be enormous compared with the size of the grains themselves. Seen from far away, and at the right angle, many dust particles scatter light together and form a faint ring. But traveling through part of the ring system might not feel like passing through a thick cloud. It would be a region of space containing more dust than its surroundings, with tiny particles moving along their orbits, silent, widely scattered, and difficult to notice without instruments. This helps us understand the word ring more accurately. A planetary ring is not a solid band. It is not one continuous disk. It is made of countless small particles, each following its own orbit, yet together forming a larger structure under the influence of gravity. Some particles are no larger than dust. Other ring systems in the solar system contain ice and much larger fragments. But in essence, a ring is a form of order created by many small objects moving around a much larger one. Jupiter makes this idea especially subtle because its rings are so difficult to see. They do not announce themselves. They require patience and the right viewing angle. This is also a lesson in astronomy. The most visible features are not always the whole story. The solar system contains many structures that are faint, dark, small, or diffuse enough to remain hidden until our instruments become sensitive enough and our perspective is just right. Before they are discovered, they still exist. They are simply waiting for us to learn how to see them. Jupiter's dusty rings are also connected to the harsh environment surrounding the planet. Jupiter has a powerful magnetic field, intense radiation, charged particles, immense gravity, and many inner moons. All these factors influence how dust moves, survives, and becomes distributed. A tiny grain is affected not only by gravity. It may also respond to sunlight, electrical charge, and the plasma within Jupiter's magnetosphere. So although the rings appear quiet, they are not lifeless structures. Their particles are constantly being shaped by many different forces. From the perspective of our journey, Jupiter's rings offer a quiet pause after the great moons. Europa, Ganymede, and Callisto raise large questions about hidden oceans, magnetic fields, and ancient surfaces. The dusty rings bring our attention back to smaller things: particles, impacts, dust, orbits, and light. But smaller does not mean less important. Many large structures in the solar system are created by small processes repeated over time. A grain of dust is thrown outward. A fragment enters orbit. A thin layer of material gradually spreads into a ring. Tiny changes, continuing across long periods, can create a structure visible only to a spacecraft with instruments sensitive enough to detect it. It is also important to distinguish Jupiter's rings clearly from those of Saturn. Saturn's rings are bright and prominent because they contain large amounts of ice that reflect sunlight effectively, and because the ring system appears much broader and denser. Jupiter has nothing quite like that. If we placed the two planets side by side in our imagination, Saturn would resemble a gas sphere surrounded by a luminous disk. Jupiter, by contrast, almost hides its rings within the darkness. Yet that difference is valuable. It shows us that the giant planets are not all alike. Each one has its own family of moons, history of impacts, and distinctive ring system. A natural question follows. Why are Jupiter's rings not brighter? Part of the answer is that they are made mainly of tiny, dark dust particles that do not reflect much light. Another reason is that the material is far less densely concentrated than in Saturn's rings. The small particles around Jupiter can also have their orbits altered by many different forces or gradually disappear, which means the rings must be continually replenished by dust created through impacts. The ring system is therefore more like a structure being maintained than something permanent that can remain unchanged forever without a continuing source of material. Seen this way, Jupiter's small inner moons become more important. They may not be as famous as Io or Europa. They do not appear in popular scientific stories about hidden oceans. They are not the largest moons in the solar system. Yet they may be the source of the dust that forms Jupiter's faint rings. A small object struck by tiny meteoroids can supply material to a structure surrounding the largest planet in the solar system. Once again, the Jovian system reveals how closely its smallest and largest components are connected. In our imagination, if sunlight passes through the rings at a shallow angle, a faint layer of dust appears beside Jupiter. It is not brilliant or sharply defined. It is only a very soft glow, like the breath of matter surrounding the planet. Behind it lies the blackness of space. Farther away are the moons. Closer in is the cloud-covered sphere, wrapped in bright and dark bands. The view is not as overwhelming as the great red spot, but it carries a beauty of its own. The beauty of something almost forgotten, suddenly becoming visible when we look from the right direction. Science often requires exactly this kind of attention. We cannot look only at the largest object, ask only about the most famous storm, or search only for worlds that may contain oceans. We must also notice dust, faint rings, tiny particles, lesser-known moons, and small impacts. The universe is built from things both enormous and minute. Jupiter can teach us about immense atmospheres, while its ring system teaches us about fine material, faintness, and quiet processes that are no less real simply because they are difficult to see. At the end of this part of the journey, the image can remain simple. A giant planet at the center. The large moons farther away, and close to Jupiter, almost blending into the darkness, a thin system of dusty rings. It does not need to shine brightly in order to matter. It only needs to exist, orbiting the planet, preserving traces of small impacts and giving us one more reason to understand that the space around Jupiter is far more complex than the unaided eye would ever suggest. From here, the journey begins to move beyond what can be easily seen. Clouds, storms, moons, and dusty rings can all be imagined directly. But surrounding Jupiter is a structure far larger than any of them, and almost completely invisible. The magnetosphere. It has no obvious color to the human eye, no surface, and no hard boundary. Yet it controls an immense region of space around the planet, guiding charged particles, creating a powerful radiation environment, and helping produce auroras. If the dusty rings are difficult to see, the magnetic field cannot be seen directly at all, yet it is far too powerful to ignore. There is a part of Jupiter that is larger than the planet itself, yet completely invisible to the naked eye. It is not the clouds, not the great red spot, not the Galilean moons or the faint dusty rings that appeared in the slanting light. This region has no surface, no clear color, and no solid boundary, where we can point and say, this is where it begins, and this is where it ends. But if a real spacecraft entered the space around Jupiter, it would have to pay immediate attention to this invisible domain. It is Jupiter's magnetosphere, the region of space controlled by the planet's immense magnetic field. Earth also has a magnetic field. It helps shape a protective region around our planet, deflecting many of the charged particles carried by the solar wind and contributing to the auroras near the poles. But Jupiter's magnetic field is far stronger, and its magnetosphere is so vast that if we could see it with our eyes, Jupiter would appear as far more than a point of light in Earth's sky. It would look like an enormous structure surrounding the planet and extending far into space. What our eyes see is only the bright cloud layer at the top of the atmosphere. What controls the environment around Jupiter is an invisible realm much larger than the planet itself. The source of this magnetic field lies deep inside Jupiter. The planet is composed mainly of hydrogen and helium. But at tremendous depths, under immense pressure, hydrogen can enter an unusual state known as metallic hydrogen. In this state, it can conduct electricity. When electrically conductive material moves inside a rapidly rotating planet, it can generate a magnetic field through a process known as a dynamo. On Jupiter, its rapid rotation, enormous size, and unusual interior combine to produce the strongest magnetic field of any planet in the solar system. The magnetic field does not remain still like a rigid steel framework surrounding the planet. It interacts with the solar wind, plasma, moons, charged particles, and Jupiter's rapid rotation. The solar wind streams outward from the Sun, carrying electrically charged particles with it. When this flow reaches Jupiter's magnetosphere, it cannot pass through easily. It is deflected, compressed on the side facing the Sun, and stretched into a long magnetic tail behind the planet. The magnetosphere is therefore not a perfect sphere. It is more like a region of influence, shaped and bent by the flow of space around it. One major difference between Jupiter and Earth is the source of plasma within the magnetosphere. Around Earth, the solar wind is an important influence. At Jupiter, a great deal of material comes from Io. This volcanic moon releases sulfur dioxide and other sulfur compounds. Some of that material escapes from Io, becomes ionized by sunlight and the environment around Jupiter, and turns into electrically charged particles. These particles form a donut-shaped region of plasma along Io's orbit, commonly known as the Io plasma torus. NASA describes how material released by Io's volcanic activity can become ionized, creating a ring-shaped cloud of ions and electrons around the Moon's orbit. Through its volcanoes, a small moon supplies material to an entire region of its parent planet's magnetosphere. This is an important idea to remember. Io is not only heated by Jupiter's gravitational pull, it also returns material to the Jovian system. That material enters the magnetic field, becomes plasma, is swept along by Jupiter's rapid rotation, and spreads around the planet. The Jovian system is therefore not a collection of isolated objects. It is a network of exchange. Gravity heats Io. Io releases material. That material becomes plasma. The plasma interacts with the magnetic field, and the magnetic field connects the moons with Jupiter's atmosphere. If plasma were visible like clouds, the region around Io's orbit would not appear empty. We would see a ring of electrically charged material surrounding Jupiter, like a vast donut suspended in space. But under ordinary conditions, human eyes cannot see this kind of emission directly. Instruments detect it through ultraviolet light, radio waves, charged particles, and changes in the magnetic field. This marks a shift from the earlier parts of our journey. We are moving away from features that can be imagined through visible images and into a region of Jupiter that must be seen through scientific instruments. The magnetosphere is also one reason the space near Jupiter is dangerous for spacecraft. Charged particles can become trapped and accelerated by the magnetic field, creating intense radiation belts. Electronic systems without sufficient protection can be damaged. A spacecraft sent to study Jupiter must follow a carefully planned orbit and avoid spending too much time in the harshest regions. Juno, for example, does not circle Jupiter in a nearly even, close orbit. It follows a highly elongated path, diving near the planet to collect data and then moving far away again, limiting the time it spends inside the strongest radiation zones. On our imagined journey, we can sit peacefully beside the window. In the real physics of this region, however, the surrounding space is anything but gentle. What makes this danger especially unusual is that it may not look dangerous at all. There are no flames, no glowing wall, and no visible wave rushing toward the spacecraft. A ship could enter a region of intense radiation while the view outside remained dark and beautiful. Only the instruments would reveal that the number of high-energy particles was increasing, that the magnetic field was growing stronger, and that the plasma environment was becoming denser. Space can be hostile in a very quiet way. What the eye sees is emptiness, while what the instruments detect is a stream of particles and force fields surrounding the planet. Jupiter's magnetosphere also produces powerful auroras near the planet's poles. On Earth, auroras are often created when particles from the solar wind travel along magnetic field lines and collide with the atmosphere. At Jupiter, material from Io and the planet's rapid rotation also play major roles. Charged particles are guided along magnetic field lines into the polar atmosphere, where they cause gases to glow at different wavelengths. Seen with the right instruments, Jupiter's polar regions are more than clouds. They are places where invisible magnetic field lines end in light. The connection between Io and the auroras leaves its own distinctive traces. Magnetic field lines can link the region around Io with Jupiter's atmosphere, creating auroral footprints associated with the Moon. JPL describes magnetic field lines connecting Io's orbit to Jupiter's atmosphere, while the plasma cloud surrounding Io contains elevated concentrations of ions and electrons. This may sound highly technical, but the central idea is quite beautiful. A moon can leave a glowing mark in the atmosphere of its parent planet without ever touching it. Through magnetic fields and charged particles alone, two worlds are connected across empty space. Ganymede makes the magnetic story even more complex. It is the only moon known to possess its own magnetic field, and it exists inside Jupiter's enormous magnetosphere. A small magnetosphere rests within a much larger one. This environment cannot be understood through color photographs alone. It requires measurements of particles, electromagnetic fields, auroras, and plasma interactions. Viewed from this perspective, the Jovian system no longer appears simply as a planet with moons orbiting around it. It becomes an electromagnetic system, with its worlds linked by invisible lines of force. This is why the magnetosphere can be called Jupiter's invisible kingdom. It does not appear like Saturn's rings. It is not beautiful in the same way as the Great Red Spot. It has no icy surface like Europa or ancient craters like Callisto. Yet it shapes the environment through which all these worlds move. It influences the radiation around the moons. It channels particles into the atmosphere. It turns the region around Jupiter into a place filled with energy. It makes the planet a vast natural generator, producing radio waves, auroras, and streams of plasma that scientific instruments can detect. One simple way to imagine it is this. If the clouds are Jupiter's face, the magnetosphere is its realm of influence. The clouds reveal the planet through color. The magnetosphere reveals the power of what cannot be seen. On one side are the bright and dark bands across the top of the atmosphere. On the other are force lines, charged particles, plasma, radiation, and interactions with the moons. Both are parts of Jupiter. One reaches the eye, while the other must be measured and heard through instruments. This also shows why science is about more than capturing beautiful photographs. If we relied only on visible light images, we would miss most of the true environment around Jupiter. A spacecraft hoping to survive must understand the radiation. A scientist studying the auroras must understand the magnetic field. To understand the plasma, we must return to Io. To understand Ganymede, we must place it within Jupiter's magnetosphere. Each question leads to another, and at the center, the giant planet continues to rotate rapidly, drawing its magnetic field and plasma into a system extending far beyond the clouds we can see. Within the rhythm of our journey, this is like dimming the visible light for a moment so we can begin to sense forces without form. We are no longer looking only at cloud bands or searching for a bright moon. We begin to notice the things that make the instruments react: rising particle counts, changing magnetic directions, radio signals, radiation warnings, and ultraviolet data from the polar regions. Jupiter does not need to shine like a star in order to control the space around it. It does so through magnetism. And once we understand the magnetosphere, the auroras in the next part of our journey will no longer seem like simple displays of beautiful light. They will become the visible expression of an invisible system. The glowing rings near Jupiter's poles are not decoration. They are where charged particles, magnetic field lines, and the atmosphere meet. They are signs that the space surrounding the planet is constantly active, even when human eyes see only darkness. So before we turn our attention toward Jupiter's poles, hold on to this idea. Around the largest planet in the solar system lies a kingdom without color, without a surface, and beyond the reach of human hands, yet powerful enough to shape the paths of particles, the glow of auroras, the environments of the moons, and the fate of any spacecraft that passes through. Jupiter is not only immense in the part we can see, it is also immense in the part we cannot. The most beautiful light around Jupiter is not found in its horizontal cloud bands, or even within the Great Red Spot. It appears near the planet's two poles, where Jupiter's magnetic field guides charged particles down into the atmosphere. To ordinary human eyes, Jupiter's auroras might not look like the brilliant scientifically processed images we often see. But when observed with the right instruments, especially in ultraviolet, infrared, or X-ray light, Jupiter's poles are not dark at all. They glow. What is an aurora? Put simply, it is light produced when charged particles enter an atmosphere and collide with atoms or molecules of gas. On Earth, auroras usually appear near the two poles, where the magnetic field guides particles from the solar wind into the upper atmosphere. These particles transfer energy to the gases, causing them to emit light. So when we see an aurora on Earth, we are not simply watching a beautiful display. We are seeing the visible trace of the sun, the magnetic field, and the atmosphere meeting one another. On Jupiter, the basic principle is similar. The magnetic field guides charged particles into the atmosphere, and the atmosphere begins to glow. But the scale and sources of those particles are very different. Jupiter's magnetic field is far stronger than Earth's, and the environment surrounding it receives more than particles carried by the solar wind. One important source is Io, the volcanic moon we encountered earlier in Chapter 10. Io releases material into space, and some of that material becomes ionized, meaning that it gains or loses electrons and becomes electrically charged. Jupiter's magnetic field captures these particles, helping create an immense region of plasma around the planet. This plasma source contributes to making Jupiter's auroras powerful, complex, and very different from those on Earth. Imagine Jupiter's magnetic field as a network of invisible pathways. They are not physical wires, but they can guide the movement of charged particles. A particle caught within a magnetic field does not move freely like dust floating through the air. It tends to spiral around a magnetic field line, traveling along that invisible path until it may eventually be directed toward the poles. When the particle enters Jupiter's atmosphere, it transfers its energy to molecules of gas. Those molecules become excited and then release light. The aurora is the visible or measurable expression of an electromagnetic process that would otherwise remain unseen. The important thing to remember is that Jupiter's auroras are not simply larger versions of Earth's. On our planet, auroral activity changes strongly in response to the sunday. When the sun releases greater numbers of energetic particles, Earth's auroras may brighten and spread toward lower latitudes. Jupiter is also affected by the solar wind, but its auroral system has an additional internal engine, the planet's rapid rotation and the plasma supplied by Io. Because of this, Jupiter's auroras can remain powerful and persistent in their own way, rather than depending entirely on space weather from the sunday. As we imagine moving closer to Jupiter's poles, we should not picture green curtains of light like those seen in photographs of Earth's northern aurora. Jupiter is a gas giant with no solid surface where an observer could stand. Its auroras occur high within the atmosphere, around the magnetic polar regions, which do not necessarily align perfectly with the planet's rotational poles. In scientific data, they appear as glowing rings, regions of emission, bright spots, and structures that change over time. There is a main auroral region, along with areas of light connected to the moons, and rapid variations that telescopes and spacecraft are still working to understand. Io leaves a particularly distinctive mark within Jupiter's auroras. Because it supplies so much plasma to the magnetic environment, and because it moves through the magnetosphere of its parent planet, the interaction between Io and Jupiter can create what scientists call an auroral footprint. This means that a glowing region appears in Jupiter's atmosphere in connection with Io's position and its interaction with the magnetic field. Io never touches Jupiter. It remains far away, orbiting the planet. Yet through magnetism and charged particles, it can still leave a mark of light near Jupiter's poles. This is one of the most beautiful details in the Jovian system. A moon can write its name in light across the atmosphere of its parent planet. The other large moons also take part in this story in their own ways. Europa, the icy moon that may conceal a salty ocean beneath its crust, moves through Jupiter's magnetosphere and interacts with the surrounding charged particles. Ganymede, the largest moon in the solar system, and the only known moon with a magnetic field of its own, makes those interactions even more complex. Callisto, more distant and ancient in appearance, also travels within the wider Jovian system. These moons are not simply points of light circling the planet. Within the magnetosphere, each one can alter particle flows, electromagnetic fields, and the luminous traces appearing in Jupiter's atmosphere. Jupiter's auroras also emit X-rays. This is scientifically important because X-rays are a form of high-energy radiation that human eyes cannot see directly. Observations from Juno and XMM Newton have helped explain one mechanism behind Jupiter's X-ray auroras. Charged ions may ride along electromagnetic waves within the magnetic field, then fall into the atmosphere and produce X-ray emissions. Put more simply, Jupiter's polar regions do not glow in only one kind of light. They emit many forms of radiation, revealing that high-energy particles are being guided, accelerated, and driven into the atmosphere by a remarkably powerful system. These details may sound technical, but the central idea is clear. An aurora is a map of a magnetic field written in light. We cannot see magnetic field lines. We cannot see charged particles with the naked eye. We do not see plasma twisting around the planet like an ordinary glowing cloud. But when those particles enter the atmosphere and cause it to shine, the invisible system leaves a visible trace. Jupiter's auroras are almost like a place where the planet reveals its electromagnetic nervous system. Within the slow rhythm of this journey, we can pause for a moment with that image. A giant planet is turning through the darkness. Below are its bright and dark cloud bands. Near the poles, light appears not from cities, fire, or a solid surface, but from an atmosphere energized by high-energy particles. The magnetic field guides them, Plasma supplies material. The moons help reshape the system. The sun still plays a role, but it is not the only presence involved. Jupiter's auroras are the result of an entire system in constant motion. This also shows why a flyby of Jupiter could never be only a sightseeing journey. With the naked eye, we can see clouds, storms, moons, and perhaps the faint rings of dust. But to understand this place, we need other kinds of eyes, as well, ultraviolet telescopes to detect glowing regions, infrared instruments to read heat and molecules, particle detectors to measure the numbers of ions and electrons, and magnetometers to trace invisible lines of force. Jupiter has more than a visible appearance. It possesses an immense electromagnetic environment, and its auroras are among the clearest signs of that hidden realm. Compared with Earth, Jupiter's auroras feel both familiar and distant. Familiar, because they are also created when charged particles meet an atmosphere. Distant, because everything on Jupiter is far larger, more powerful, and more complex. No one stands beneath a polar sky and looks upward. There is no snow, no pine forest, and no Arctic horizon. Instead, there is the hydrogen and helium atmosphere of a gas giant, the strongest planetary magnetic field in the solar system, plasma supplied by a volcanic moon, and glowing regions recorded by telescopes and spacecraft. The sight is beautiful not because it resembles Earth, but because it is so different from Earth while still following laws that we can understand. Charged particles move through a magnetic field, atmospheric gases absorb energy and begin to glow. Moons interact with a planet. Light becomes a signal. Scientists read that signal to understand a region of space that human beings could never touch. This is how science transforms a distant glow into information. Within the deeper structure of the auroras, rapid changes also occur. The light may intensify, grow fainter, shift position, or appear as bright points and streaks of emission. These changes show that the plasma and magnetic environment surrounding Jupiter is never still. It contains currents, waves, electric fields, particles from Io, influences from the solar wind, and the effects of the planet's rapid rotation. If Jupiter's clouds are evidence of a dynamic atmosphere, then its auroras are evidence of a dynamic magnetosphere. At this moment, our imagined spacecraft can tilt gently toward the polar region. Instead of looking sideways across the cloud bands, we turn toward the place where the magnetic field lines converge. The auroral light does not need to be described as overwhelmingly brilliant. It is enough to see it as a cold ring of light, a faint region of emission slowly brought into focus by the instruments. Within the darkness surrounding Jupiter, that glow reveals that the planet is doing more than simply rotating. It is interacting with the entire region of space around it. Once again, Io returns to the story, but not through the volcanoes visible on its surface. It returns through material that has escaped from the moon, entered the plasma, and helped supply the streams of charged particles surrounding Jupiter. Europa, Ganymede, and Callisto are no longer merely distant icy worlds. They are objects moving through a powerful magnetic environment, leaving effects that scientific instruments can measure. The Jovian system resembles an immense network in which surfaces, clouds, moons, plasma, magnetic fields, and auroral light are all connected. The auroras therefore form a beautiful bridge between what can be seen and what cannot. We see light, but that light tells us about a magnetic field. We see the polar region glowing, but behind it are charged particles. We see a bright mark associated with Io, but behind that mark are volcanoes, plasma, and orbital motion. No detail stands alone. Everything in the Jovian system seems to be connected by invisible threads. As this part of the journey draws to a close, allow the image to slow down. Jupiter continues to turn. Its cloud bands continue circling the planet. At both poles, the auroras glow quietly in wavelengths that human eyes cannot always see. The moons continue along their orbits. Material from Io continues to feed the plasma environment. The magnetic field continues guiding particles into the atmosphere. The space around Jupiter is not silent in a physical sense. It is filled with particles, waves, force fields, and light. Yet from our imagined seat, everything still appears slow, distant, and quiet enough to be heard through curiosity. After the auroras, our journey will enter the harsher side of this same system. The charged particles that produce beautiful light can also create a dangerous radiation environment. One part of the system makes Jupiter glow near its poles. while another forces spacecraft to be carefully protected as they pass nearby. Beauty and danger are not separate here. Both arise from the powerful magnetic field, the plasma, and the energy of the largest planet in the solar system. There are dangers in space that never roar. They do not appear as a red storm. They do not twist into an enormous oval. They do not glow brilliantly like the auroras near Jupiter's poles. They are simply there, silent, invisible, passing through space like tiny needles of energy. To the naked eye, the region around Jupiter still looks beautiful. The largest planet in the solar system still appears wrapped in soft cloud bands, with distant moons and bright and dark regions drifting slowly across its face. But for a spacecraft, that beauty is far from simple. Jupiter is surrounded by an intense radiation environment, and this is one reason approaching the planet is far more difficult than simply flying toward a beautiful view. Here, radiation can be understood as high-energy charged particles moving through Jupiter's magnetic environment. They do not form a visible wall. They have no color of their own within the darkness. Yet they can penetrate materials, interfere with instruments, damage electronic components, or corrupt data if a spacecraft is not properly protected. As human beings, we tend to fear things with clear forms: fire, rocks, collisions, or powerful winds. But around Jupiter, one of the greatest dangers has no visible shape at all. It is so quiet that without instruments, we might barely realize we were entering an extremely hostile region. The source of this environment lies within Jupiter's own invisible power. The planet has an immense magnetic field. A magnetic field is a region of force capable of influencing charged particles and guiding them along invisible paths around a planet. Earth also has a magnetic field, which helps produce auroras near the poles. But Jupiter's magnetic field is far stronger, far larger, and active within a much more complex environment. It traps electrons and ions, electrically charged particles, and causes many of them to move faster, carry more energy, and become increasingly dangerous to spacecraft. Within this system, Io remains an important presence. Io is the volcanic moon we encountered in Chapter 10, where Jupiter's gravitational pull heats its interior and drives intense volcanic activity. Material released by Io's eruptions does not all fall back onto the moon's surface. Some of it escapes into space, becomes ionized, and turns into plasma, a state of matter made of charged particles. Jupiter's magnetic field captures this plasma, adding more material to the energetic environment surrounding the planet. Put more simply, Jupiter pulls on Io so powerfully that Io erupts, and material from those eruptions then returns to make the space around Jupiter even more active and hazardous. It is a strange chain of connections. A planet pulls on a moon. The moon heats from within. Volcanoes release material into space. That material becomes electrically charged. The planet's magnetic field captures those particles, and the entire region around Jupiter becomes filled with energy. To the eye, the planet may appear peaceful, but physically, this is not true stillness. It is the stillness of a place where the most powerful motion is happening on a scale the human eye cannot see. A spacecraft entering this region needs more than the correct trajectory. It needs protection. The electronic systems inside the spacecraft are like the mission's brain: cameras, magnetometers, particle detectors, memory, computers, and the systems that transmit data back to Earth. If radiation damages them, the spacecraft may continue flying, but its ability to observe and describe what it encounters can be greatly reduced. So at Jupiter, the question is not only, how do we get there? It is also, how do we survive long enough to learn something? NASA's Juno spacecraft offers a clear example. It was sent to study Jupiter, but engineers understood from the beginning that the planet would not be a gentle destination. Juno's most important electronic components were placed inside a specially protected compartment with titanium walls, like a reinforced room within the spacecraft. This vault cannot block every high-energy particle, but it reduces the effects of radiation and helps sensitive equipment survive for longer. Behind every beautiful image from Juno lies a quiet truth. To photograph Jupiter, the spacecraft must pass through an environment capable of damaging it. Juno's orbit was also calculated with great care. It does not remain close to Jupiter for too long during each pass. Instead, the spacecraft dives toward the planet to gather data, then travels far away again, like a diver descending into deep water, only for as long as necessary before returning to a safer depth. This flight pattern allows Juno to observe important regions while reducing the time it spends within the most intense radiation zones. It is a very different kind of courage from what we see in movies. It is not loud or reckless. It is simply precision, patience, and a clear understanding of how much the spacecraft's materials can endure near such a powerful planet. Radiation may be difficult to imagine because it has no obvious shape. Think of sunlight. We can see the light and feel its warmth, but ultraviolet radiation, which can damage the skin, does not appear as a separate color before our eyes. The radiation around Jupiter is similar, though it belongs to an environment that is much more distant, energetic, and extreme. Something does not have to be visible to have an effect. It does not have to make a sound to be dangerous. In space, some of the greatest hazards arrive in silence. This radiation environment also affects Jupiter's moons. Europa, the icy moon that may conceal an ocean of salty water beneath its surface, is bombarded by high-energy particles. This makes studying Europa more complicated because its upper ice has likely been altered by radiation over very long periods. If scientists hope to find signs connected to the ocean below, they must understand how the surface has been processed by the environment outside. Ganymede, the largest moon in the solar system and the only known moon with its own magnetic field, interacts with Jupiter's magnetic environment in a more unusual way. Callisto lies farther away, where the radiation environment is less intense than it is closer to the planet. Moving only a little closer to or farther from Jupiter can produce very different conditions. This helps us understand that the Jovian system is not a flat stage. It has inner regions and outer regions, violent zones and places that are less extreme. Each moon travels through its own environment. Every orbit carries its own level of danger. Every mission must choose its path as carefully as someone selecting a route through a powerful current. Science needs more than meaningful questions. It also needs a trajectory wise enough to keep the spacecraft alive after those questions have been asked. There is a strange beauty in this idea. Before us, Jupiter remains magnificent. Its auroras continue glowing quietly. Its cloud bands circle the planet. Its moons continue along their orbits. Yet within that beauty is an environment that leaves no room for carelessness. Jupiter is not trying to attack a spacecraft. It is simply being what it is. An enormous, rapidly rotating planet with a powerful magnetic field, plasma supplied by Io, and high-energy particles trapped within its region of influence. The danger does not come from intention. It comes from physics. This is what gives our imagined flight past Jupiter greater depth. If we speak only of beauty, we see a striped planet with storms, auroras, and moons. But when we look one layer deeper, we understand that each beautiful sight comes with its own conditions. Auroras are beautiful because charged particles enter the atmosphere. Yet those same particles are also part of a dangerous radiation environment. The magnetic field creates strange light near the poles, but it also traps high-energy particles around the planet. Io makes the Jovian system more dynamic, but material from Io also helps feed the surrounding plasma. Beauty and harshness are not separate here. They are two sides of the same system. A photograph of Jupiter can appear perfectly peaceful. It may rest on a screen like a calming image of space meant for sleep. But to capture that photograph, a real spacecraft had to endure cold, radiation, immense distance, and the long delay of sending signals back to Earth. Behind the gentleness of the image lies a patient and persistent story of engineering. People calculated the orbit. Engineers considered every component. Scientists waited years for data. And a small spacecraft traveled through a region of space the human body could never survive, simply to send home a few fragments of truth. For a moment, imagine our spacecraft moving beyond Jupiter's bright cloud tops. The surrounding space is dark and vast. Jupiter is close enough to become unforgettable. Inside the spacecraft, instruments continuously record particles, magnetic fields, radiation, and signals. Outside, nothing appears chaotic. That contrast creates the feeling of this part of the journey. Beauty can be very quiet, but it is not always gentle. A place can invite us to keep looking, while also requiring us to maintain our distance. And the more we understand Jupiter's radiation environment, the clearer the next question becomes. If simply orbiting the planet is already this difficult, what would happen if we tried to travel deeper inside it? If we passed through those beautiful clouds, Would there be anywhere to stop? Is there solid ground waiting below? Or would the pressure, temperature, and changing states of matter become increasingly extreme until they exceeded everything a spacecraft could endure? Jupiter is directly before us, beautiful and immense. But that beauty is not an invitation to land. It is a reminder that some worlds can only be approached with great care. In the next chapter, we will ask a question that many people have wondered while looking at this planet. Could you fly into Jupiter? A question naturally arises once Jupiter is close before us. If those cloud layers are so beautiful, if the bright and dark bands stretch around the planet like rivers, could we travel down beneath them? Not merely fly past, not simply look inward from outside, but truly descend through the white clouds, past the reddish-brown regions and the layers of gas that create Jupiter's famous face, and discover what lies below. Another layer of clouds, a deep ocean, a solid core, or perhaps some hidden ground that has never revealed itself from a distance. The question feels natural, because human beings live on Earth. To us, a planet usually has a surface. Beneath the clouds lies the lower sky. Beneath the sky are mountains, oceans, plains, cities, deserts, and ice. Even Mars, cold and dry as it is, still has ground where spacecraft can land. The Moon has no thick atmosphere, but it has a gray, dusty surface where footprints can remain. This experience trains our imagination to keep searching for a floor at the end of every descent. Jupiter offers us no such thing. It is not a rocky planet covered by an atmosphere. It is a gas giant composed mainly of hydrogen and helium. But the word gas can be misleading here. It does not mean that Jupiter is like a light cloud we could simply fly through and emerge from on the other side. Near the top, the material may be relatively thin. Farther down, the weight of the entire planet presses upon the layers below. Pressure increases. Temperature rises. Hydrogen, which on Earth we usually think of as an extremely light gas, becomes so compressed that it no longer behaves as it does under familiar conditions. As you descend, the boundary between gas and liquid does not appear as a clear dividing line. There is no ocean surface where the gas ends and liquid begins. Everything changes gradually, becoming heavier and denser. Deeper still, under immense pressure, hydrogen can enter a state known as liquid metallic hydrogen. This is an unusual form of matter in which hydrogen is compressed so strongly that it can conduct electricity. This deep region of electrically conductive material is believed to help generate Jupiter's powerful magnetic field, the same field that guides charged particles, creates auroras, and makes the environment around the planet so dangerous, as we explored earlier. The first answer, then, is already clear. If we search beneath Jupiter's clouds for solid ground like the surface of Earth, we will not find it. There are no plains where a spacecraft could land, no cliffs it could hold onto, no surface ocean upon which it could float. There are only layers of matter becoming deeper, heavier, and increasingly removed from anything in ordinary human experience. Imagine a small probe beginning to fall into Jupiter's atmosphere. At first, it passes through the cloud layers that looked so beautiful from a distance. Sunlight filters through gases and cloud particles. The creamy whites, browns, and oranges are no longer patterns painted across a sphere. They become an environment surrounding the probe on every side. Jupiter is no longer something outside the window. Now Jupiter is everywhere around it. For a brief time, the idea sounds almost magical. This is what human beings have always wanted to do with distant worlds. Not only observe them, but touch them through our machines. Not merely measure them from outside, but enter a small part of their interior. Yet Jupiter does not allow a visitor to descend very far. Pressure begins to close around the probe. The temperature rises. The winds become more violent. Signals must travel through an increasingly dense and complex environment to reach the main spacecraft. With every passing minute, the world surrounding the probe becomes less welcoming to any machine. We know this not only through imagination. In 1995, NASA's Galileo mission released a probe into Jupiter's atmosphere. It was not sent there to land, because there was nowhere to land. It was sent to measure, listen, and sample the atmosphere through scientific instruments, transmitting data until the environment destroyed it. For about 58 minutes, the Galileo probe returned information about temperature, pressure, winds, atmospheric composition, and the conditions within Jupiter's atmosphere. Then it fell silent. Only 58 minutes. But those 58 minutes were extraordinarily valuable. A small machine separated from its parent spacecraft and plunged into the largest planet in the solar system. It did not see a surface waiting below. It had no final landing place. It simply descended, sending back data little by little as pressure and temperature increased around it. Eventually, at some depth, the conditions exceeded its limits. The signal ended. The probe never returned. It became a tiny part of Jupiter, but before disappearing, it helped humanity understand more about a world no person could ever enter. There is a quiet beauty in that story. Not the beauty of a color photograph, an aurora, or an icy moon. It is the beauty of a brief scientific moment. A small machine, built with the knowledge that it would not survive for long, still descending so it could send back numbers. Those numbers may sound dry, but they were the only way a world like Jupiter could tell us something about its interior. For a crewed spacecraft, there would be no uncertainty in the answer. It could not be done. Not only because the radiation outside Jupiter is dangerous, not only because the winds within the atmosphere can be extremely powerful. The fundamental reason lies in the structure of the planet itself. There is nowhere to stop, no safe layer where a spacecraft could rest, no ground on which it could land. The deeper it traveled, the less the journey would resemble a flight, and the more it would become a process of being swallowed by increasingly compressed matter. The hull would face crushing pressure from every direction. The temperature would continue rising, signals would weaken. Familiar ideas such as sky, altitude, ground, and horizon would gradually lose their meaning. An airplane on Earth can pass through clouds and emerge into clear air. A spacecraft can land on the moon because there is a solid surface beneath it. Entering Jupiter is nothing like either of those experiences. The upper clouds are not a thin veil hiding land below. They are the entrance to an immense column of matter extending far into the planet. From the outside, the cloud bands appear soft and gentle. From within, they are only the beginning of an environment that becomes increasingly unforgiving. This changes the way we look back on everything we have already seen. The belts and zones, the bright and dark bands in Jupiter's atmosphere, are no longer simply beautiful lines wrapped around the planet. They are the uppermost part of a system reaching far deeper below. The Great Red Spot is no longer merely a famous storm. It is an enormous vortex on a planet with no solid ground for the storm to cross and weaken over, as storms often do on Earth. The auroras near the poles are not only beautiful light. They are connected to a magnetic field generated by matter moving far inside the planet. Jupiter's radiation environment is not a secondary detail. It is evidence that this world controls the space around it through invisible power. Everything connects again. The clouds lead downward into Jupiter's internal structure. The magnetic field leads back to liquid metallic hydrogen. The auroras lead to charged particles. The radiation leads to the magnetosphere. So the question, could you fly into Jupiter, is not an isolated one. It lies at the meeting point of almost everything we have seen: the beauty outside, the power within, and the limits of exploration. Here, it is important to keep a sense of balance. Jupiter is not a monster. It does not want to crush any spacecraft. It has no intention at all. It simply exists according to its own physics, immensely large, extremely massive, rapidly rotating, filled with enormous amounts of hydrogen and helium, with pressure increasing with depth, a powerful magnetic field, and a vast radiation environment. Jupiter's danger does not come from aggression. It comes from scale, and that scale teaches human beings to respect distance. There are worlds where we can set foot. There are worlds we can only fly past. And there are worlds like Jupiter, which allow us to approach their outer edges, look deeper with instruments, release a probe for a brief descent, and then accept that most of what lies within remains beyond our direct reach. That does not mean science has failed. On the contrary, it reminds us that exploration is not always about taking possession of a place. Sometimes, exploration means knowing that we cannot go any farther, yet still finding a way to understand more. The Galileo probe did not land. It did not return. It did not survive for long. But in less than an hour, it did something the human eye could never do. It entered Jupiter and transmitted data from within. Juno does not plunge into the atmosphere to destroy itself. Instead, it follows carefully designed orbits around the planet, reading its magnetic field, gravity, deep clouds, and auroras from a safer distance. Each mission chooses its own way of approaching. One instrument descended and fell silent. Another continues circling patiently through repeated orbits. Both show that science does not require a loud victory. It requires precision, patience, and a very quiet kind of courage. If, on this imagined journey, we turn the spacecraft toward the clouds below, the first view might be mesmerizing. But the more we understand Jupiter, the more clearly we know when to stop. Not because our curiosity has faded, but because the best form of curiosity does not always mean sending a body deeper. Sometimes it means keeping enough distance to continue observing. A spacecraft destroyed too quickly can no longer tell us anything. A spacecraft that knows when to pull away can continue returning data, images, and new questions. So the gentlest answer to the question of this chapter is this: we can enter Jupiter for a short distance with an automated probe, as Galileo once did. We can measure part of its atmosphere. We can learn from those brief and precious minutes. But we cannot fly through Jupiter as though passing through a bank of fog. We cannot land on it as we land on Mars. We cannot find a secret surface waiting beneath the clouds. Jupiter has no floor at the end of the descent. It has depth. That depth is what makes the planet so remarkable. A world without a solid surface can still have weather. It can have storms without land. It can have immense cloud layers without blue oceans. It can have magnetic fields, auroras, dusty rings, and a dynamic family of moons without offering any place to stand. Jupiter is nothing like our home, yet it is still a world in every meaningful sense, simply a different kind of world, where matter forms not mountains and oceans, but layers of gas, liquid, pressure, and force fields. From a safe position, the spacecraft goes no farther down. It maintains its distance and allows Jupiter to continue drifting beneath the view. The cloud bands once again become a vast painting. The polar regions still glow far away. The moons continue along their separate orbits. The faint dusty rings remain almost hidden in darkness. But after asking this question, the scene no longer feels as it did before. We are not merely looking at the beautiful exterior of a planet. We know that beneath that beauty lies a depth no human being could ever step into. And it is precisely this inaccessibility that gives Jupiter its unique fascination. It does not invite us to land. It offers no surface where we might plant a flag, build a station, or leave a footprint. Instead, it invites us to do something more difficult and more humble. Observe, measure, reason, accept our limits, and still remain curious. Jupiter is not a doorway to pass through. It is an abyss made of matter, light, pressure, and time. We cannot reach its end, but from its outer edge, simply by looking long enough, we have already learned so much. And now, rather than trying to descend farther, the journey begins to pull away. Not because there is nothing left to see, but because sometimes a wider distance is needed to understand the whole view. As Jupiter slowly grows smaller in the window, everything we have passed, the clouds, storms, moon shadows, Io, Europa, Ganymede, Callisto, the dusty rings, magnetic field, auroras, and radiation begins to gather into a single image, not merely a planet, but an immense system turning through the darkness. Distance begins to do what it always does in the universe: transform enormous details into an image that feels smaller, quieter, and easier for the human eye to hold all at once. Jupiter no longer fills the entire view as it did when the spacecraft passed close above its cloud layers. The bands of white, brown, pale yellow, and muted orange are still there, but they gradually gather into soft lines across a bright sphere. The great red spot, the storm that once made Earth seem small in our imagination, now contracts into a deep-colored mark among the clouds. Smaller vortices, wisps of clouds stretched into threads, and bright and dark regions that once appeared as an entire world in motion begin to merge together. Not because they have disappeared, but simply because we are moving away. There is a very different feeling in looking back at a place after coming to understand it more deeply. At first, Jupiter was a point of light. Then it became a striped planet. Then those stripes became an atmosphere, winds, chemical clouds, belts, and zones, the dark bands and bright regions created by streams of gas flowing around the planet. The Great Red Spot is no longer merely the famous red mark seen in photographs, but an ancient storm, an immense atmospheric vortex resting between powerful jet streams. The clouds are no longer soft layers of cotton. They are signs of ammonia, water, other compounds, temperature, pressure, and motion. The image remains the same, but after the journey, our eyes no longer read it in the same way. This is one of the beautiful things about science. It does not necessarily make a scene feel more complicated or heavy. It gives the scene depth. A streak of color is no longer only color. A round shadow crossing the clouds is no longer simply a dark spot. A glowing ring near the pole is no longer only light. Each feature has become connected to a cause, a process, and a question. Jupiter no longer resembles a distant painting hanging in space. It has become a system with a physical life of its own. From our steadily increasing distance, the great moons also begin to appear differently. Io, the volcanic moon closest to Jupiter, no longer reveals its yellow-orange surface and sulfur-covered regions as clearly as it did nearby. It returns to being a small point of light. Yet that point now carries the entire story of tidal forces. Jupiter's gravitational pull, combined with orbital resonance among the other moons, heats Io from within and drives the most intense volcanic activity in the solar system. A small point of light, once understood, is no longer truly small. Europa is the same. From far away, it is only a cold, bright object, difficult for the naked eye to distinguish from the other points of light without a label. But in the memory of this journey, Europa still carries its fractured ice and the question of a salty ocean hidden far beneath the surface. We do not need to see that ocean directly. Simply knowing that it may exist transforms that tiny point into one of the most intriguing places in the solar system. A moon does not need a violent appearance to be important. Sometimes, the greatest part of a world lies beneath a silent crust. Ganymede, the largest moon in the solar system, also recedes into a small point within Jupiter's realm of influence. But its name is no longer empty. Ganymede is a world larger in diameter than Mercury, with a magnetic field of its own and possible layers of water hidden inside. It reminds us that a moon does not have to be small in scientific meaning. Some natural satellites are complex enough to resemble planets in their own right. Callisto lies farther away, quieter, and older. Looking back, it appears as a point of light, keeping its distance from the violence closer to Jupiter. Yet we know that its surface is densely covered in impact craters, like an archive of time. It does not erupt like Io, raise the same powerful questions about an ocean as Europa, or stand out through a magnetic field like Ganymede. Callisto seems slow, and that slowness is what makes it valuable. A world where old marks are rarely erased can preserve memories that more active places have worn away. The 4 Galilean moons are no longer simply 4 points of light around a large planet. They have become 4 different ways that matter can respond to the same gravitational environment. Io responds with fire, Europa with ice and a hidden ocean, Ganymede with size, a deep internal structure, and its own magnetic field. Callisto with ancient impact scars. From far away, all of them become small again, but understanding keeps them from disappearing into the darkness. Jupiter remains at the center of the entire scene. From this distance, we can no longer see each individual current of wind, but we know they are still there. We cannot hear the auroras, but we know the polar regions continue glowing in wavelengths the human eye cannot always detect. We cannot see the magnetosphere as a colored boundary, but we know that an immense invisible kingdom surrounds the planet, where charged particles are guided, plasma from Io enters the electromagnetic environment, and radiation forces spacecraft to be carefully protected. What cannot be seen remains present in our understanding. Jupiter's thin ring system also nearly disappears. Even when we were close, it was difficult to see, becoming visible only when the light struck it at the right angle. Now, as the planet grows smaller, the dusty rings once again blend into the darkness. Yet they have already played their part in the journey. They reminded us that not everything important needs to shine brightly. Some structures are made only of dust, faint, diffuse, and delicate, yet still tell stories of impacts, small moons, and material held in orbit. The universe is not made only of grand spectacles. It is also built from tiny particles following the right paths over immense stretches of time. The farther we move from Jupiter, the more it begins to resemble the image people often see in books, a striped sphere with small moons nearby. But this is where the difference becomes clearest. The image may look much as it did at the beginning, but the observer has changed. Before, a stripe was simply a stripe. Now it is an atmosphere. A red spot was only a red spot. Now it is a storm. A point of light was only a point of light. Now it may be Io, Europa, Ganymede, or Callisto, each carrying a history of its own. Science does not always change the landscape, it changes the way we see it. As we pull farther away, the humility of the journey becomes easier to feel. We did not land on Jupiter. We did not fly through it. We did not reach its core. We did not touch the liquid metallic hydrogen deep inside. We did not stand beneath its auroras. We did not walk across Europa and examine the fractures in its ice. We did not place a hand against the impact craters of Callisto. Yet we have still traveled through a wide field of observation, from distant light to clouds, storms, moon shadows, volcanoes, ice, possible oceans hidden below the surface, dusty rings, magnetic fields, auroras, radiation, and the question of a depth where no landing is possible. This is how human beings usually come to understand the universe. Not by being physically present everywhere, but by connecting signals. An image from a telescope, a measurement from a spacecraft, a stream of data from the Galileo probe during its brief 5-8-minute descent, Juno's carefully planned path around the planet, a model of the atmosphere, a magnetic measurement suggesting an ocean beneath Europa. No single fragment tells the whole story, but placed together, they build a picture deep enough to transform a point of light in the night sky into an entire world. Jupiter continues to rotate. This sounds simple, but by the end of the journey, it carries a different weight. It spins rapidly, drawing its clouds into bands. It holds the moons in their orbits. It generates an immense magnetic field. It sustains storms that can last for generations. It allows moon shadows to glide across its clouds. It pulls and heats Io, may help Europa preserve water beneath its ice, and surrounds Ganymede and Callisto with an environment that is both scientifically rich and physically harsh. A planet turning in darkness, yet never isolated. From even farther away, the details continue to retreat into silence. The great red spot grows smaller. The cloud bands soften. The moons become a few bright points surrounding a sphere. Given enough distance, Jupiter will once again become the point of light. It was at the beginning a point visible to someone standing on Earth at night, unaware of how many layers of story it contains. But after this journey, that point is no longer simple. It has become a doorway that once opened. Perhaps this is the most beautiful feeling in looking back at Jupiter. The farther away we travel, the more clearly we understand that a world does not need to remain close in order to keep its meaning. It may shrink within our field of view, but it does not shrink within our understanding. What we have learned remains with us. A gas giant without solid ground, an atmosphere painted by winds, a storm larger than Earth, a family of moons far more diverse than the first glance suggests, an immense invisible magnetic field, an environment both beautiful and dangerous, a depth that human beings have been able to measure only for a few brief moments. The growing distance also softens the journey. Up close, Jupiter was too vast, too powerful, almost overwhelming every other sensation. From farther away, it becomes part of the solar system once again. The sun lies off to one side, appearing smaller, but still providing the light. The other planets continue along their separate orbits. Earth is very far away, blue and small, where the listener may be resting in a quiet room, hearing a story about a planet that can never be touched. Distance is no longer merely physical. It becomes a pause in which to understand what we have just seen. And perhaps it is only now that we realize this flight past Jupiter was never truly about answering the question, "What would you see?" It also answers something deeper. After looking at another world for long enough, how does the way we see our own world begin to change? Jupiter is nothing like Earth, yet it makes Earth feel more precious. A place with solid ground, a gentle atmosphere, liquid water on its surface, and a sky that human eyes can look into without a titanium shield or a carefully calculated orbit. By looking at a planet where no landing is possible, we understand more clearly the value of the planet beneath our own feet. Jupiter continues to grow smaller. It does not disappear at once. It slowly becomes a distant sphere, and then a point of light among many others. But within that point are now clouds, storms, moons, dusty rings, a magnetic field, auroras, and questions that remain unanswered. We have brought no physical material back from Jupiter. We have kept no fragment of cloud, no grain of ring dust, and no ray of auroral light. What we bring back is a way of seeing. A planet is more than its image. It is its history of formation, its internal structure, its atmosphere, its gravitational relationships, everything visible and invisible, the measurements we make, and the limits humanity must respect. Jupiter has shown us this with unusual clarity. The closer we came, the more complex it became. The farther away we moved, the more it settled into a quiet symbol of scale. Ahead, the journey no longer needs another grand spectacle. We have passed through enough clouds, storms, moons, and invisible regions. What remains is a return to the listener's own sense of place, to a quiet room on Earth, and to the question that lingers after an imagined journey past the largest planet in the solar system. Jupiter continues to rotate far away, and from our safe and very small distance, we begin to hold on to what it has left within us. In the end, Jupiter returns to distance. It is no longer the enormous sphere filling the entire view, no longer the vast cloud layers, where even a small streak could be larger than a country. No longer the feeling of standing before a world without solid ground, where every question about landing dissolves into pressure, temperature, and depth. The planet slowly recedes, just as gradually as it grew at the beginning of the journey. But this time, it is no longer an anonymous point of light in the darkness. It now carries weight in our memory. A point of light in the sky can deceive us with its apparent smallness. From Earth, Jupiter is only a steady bright dot, sometimes more noticeable than the stars around it, but still only a dot. We may see it and then forget it. We may walk beneath a clear night sky, look up for a few seconds, and then return to the room, the sound of a fan, the glow of a lamp, and the small concerns of everyday life. But after this journey, that point of light is no longer flat. It has depth. It has layers. It contains clouds, storms, moons, dust, magnetic fields, radiation, and regions of matter that no spacecraft could ever explore to their end. This is the first thing Jupiter leaves with us, a new way of seeing things that appear small. At the beginning, we approached a planet, but the farther we traveled, the more that planet opened into an entire system. The bands of color across Jupiter were no longer patterns. They became a flowing atmosphere, stretched into belts of wind by the planet's rapid rotation. The bright and dark regions were no longer decorative colors, but signs of high clouds and deep clouds, rising gas and sinking gas, layers of ammonia and water, and other compounds mixed through an atmosphere with no rocky floor beneath it. The Great Red Spot was no longer merely a famous red mark. It became a storm that has endured through generations of human observation, a vortex so vast that Earth seems small when we place it beside the storm in our imagination. Then there were moments smaller in scale, yet no less strange. The round shadow of a moon crossing the cloud tops, a dark point gliding quietly over the largest planet in the solar system. The scene was not loud, but it made something very clear. Jupiter does not stand alone. Other worlds are moving around it. Io burns from within because of tidal forces. Europa carries a fractured icy shell and the possibility of a salty ocean far below. Ganymede is larger in diameter than Mercury, and possesses a magnetic field of its own. Callisto preserves impact craters across its surface like old memories of the solar system. The 4 bright points near Jupiter are no longer background details. They are 4 different stories of how matter responds to gravity, time, and internal heat. What remains memorable is not only each individual world, but the relationships between them. Jupiter pulls on Io. Io heats up and releases material into space. That material becomes ionized, turns into plasma, and is swept into Jupiter's magnetic environment. The magnetic field guides charged particles toward the poles, creating auroras. The same system produces beautiful light and a radiation environment so dangerous that spacecraft must be protected with extraordinary care. Beauty and harshness are not separate here. They are 2 sides of the same planet. This is where Jupiter becomes deeper than an ordinary astronomical image. It is not only beautiful, it has structure. It is not only large, it has influence. It does more than orbit the Sunday. It holds around itself an entire region of matter, moons, force fields, and invisible processes. If the clouds are Jupiter's face, then the magnetic field is its realm of influence. If the Great Red Spot is its most recognizable symbol, then radiation is the quiet reminder that the space around this planet is far from empty. If the moons appear as tiny points in an image, then understanding them reveals that each point is a world with its own history. Near the end of our journey, the question, "Could you fly into Jupiter?" brought us to the limits of imagination. Human beings often want to enter things in order to understand them. We want to open the door, find the core, place our feet on a surface. But Jupiter does not offer that kind of access. There is no solid ground on which to land, no surface ocean upon which to float, no final layer where a spacecraft could stop and look around. The deeper it descends, the more pressure rises, the more temperature increases, and the more hydrogen is compressed into unfamiliar states. Somewhere within, liquid metallic hydrogen may help generate the planet's powerful magnetic field, but that is not a place meant for a visit. The Galileo probe gave us a quiet image of that limit. A small instrument fell into Jupiter's atmosphere, transmitted data for 58 minutes, and then went silent. There was no return, no successful landing, no footprint left behind. There were only brief measurements, enough to teach humanity more about the temperature, pressure, winds, and atmospheric composition of an overwhelmingly large world. Those 58 minutes were like a whisper from inside Jupiter. Brief, but precious. Fragile, yet enough to change our understanding. Perhaps this is one of the most moving images in planetary science. A small machine disappearing into a giant planet, and before it vanishes, managing to send home a few fragments of truth. It was not a loud victory. It was not conquest. It was only a brief contact between human curiosity and a place almost beyond reach. That very briefness gives the data its weight. It reminds us that understanding does not always come from remaining somewhere for a long time. Sometimes, it comes from a moment courageous enough, precise enough, and patient enough to enter one of the hardest places to reach and listen for a very short while. Jupiter therefore teaches us a different kind of humility. It is not that our smallness makes us powerless, but that it makes our approach more subtle. We cannot travel through this planet, so we learn to orbit it. We cannot see a magnetic field with our eyes, so we build instruments to measure it. We cannot set foot on Europa, so we read the fractures in its ice and the signals within the magnetic field. We cannot look directly into the ocean below, so we use orbits, light, models, and measurements to infer what may be there. We cannot survive Jupiter's radiation environment, so we place the electronic brain of a spacecraft inside titanium shielding and choose its path with extraordinary care. Exploration does not always mean moving forward. Sometimes, exploration means recognizing where we cannot go and still finding a way to understand. That is why our flight past Jupiter does not end in disappointment because we cannot land. On the contrary, the impossibility of landing is part of what makes this planet so different. Jupiter does not need to resemble Earth in order to inspire affection. It has no forests, no blue surface oceans, no soft ground, and no sky beneath which the human body could safely stand. Yet it possesses a beauty of its own, the beauty of matter compressed at great depth, of an atmosphere drawn into bands, of storms that outlive human lives, of auroral light created by invisible particles, and of small moons transformed by gravity into worlds of volcanoes, ice, and ancient impact scars. Jupiter expands the meaning of the word world. A world does not need solid ground. It does not need life. It does not need to welcome us. A world can be too powerful to approach closely, too deep to touch, and too dangerous to remain near for long, yet still deserve decades of observation. It still has a story, and that story is no less real simply because human beings cannot walk upon it. Seen from here, Earth also begins to feel different. After imagining a planet with no surface on which to land, the ground beneath our feet no longer seems ordinary. The air in the room, the glass of water nearby, rain beyond the window, and a row of trees in the evening light all belong to a kind of world that is rare within our experience. Earth has an atmosphere gentle enough to breathe, pressure moderate enough for the body to endure, liquid water exposed across its surface, and solid ground that supports us without asking us to think about it every day. Jupiter does not make Earth seem smaller. It makes Earth feel more precious. But that preciousness should not become a feeling of isolation. Earth is home, while Jupiter reminds us that our home belongs to a solar system containing far more kinds of worlds than we usually remember. There are rocky planets, gas giants, icy moons, volcanic moons, dusty rings, asteroids, comets, magnetic fields, radiation, hidden oceans, and dark regions that remain only partly understood. The universe is not monotonous, even within our own planetary system. Traveling only as far as the fifth planet brings us to a structure so rich that even a long video can explore its layers only one careful step at a time. What Jupiter leaves behind is not a complete answer. It leaves us with better questions. How will the Great Red Spot change in the future? How exactly do Jupiter's deeper cloud layers behave? What is the shape of the planet's core, and how thoroughly is it mixed with the material around it? If Europa's ocean exists, does it come into contact with the rock below in a way that could produce rich chemistry? What internal mechanism allows Ganymede to maintain its own magnetic field? At what rate are Jupiter's dusty rings replenished and lost? Not every question needs to be answered tonight. Some questions are beautiful because they remain open. For a video made for sleep, the ending should not leave the listener tense because of everything still unknown. It should leave behind the feeling that not knowing can also be gentle. The unknown is not a frightening emptiness. It is a space where curiosity can continue to breathe. Jupiter has been observed since ancient times, viewed through telescopes, visited by passing spacecraft, measured by Juno, and modeled by generations of scientists, yet it still holds secrets. Sometimes, the more we learn about a planet, the deeper it becomes rather than the smaller. There is something beautiful in that. Imagine returning now to a quiet room on Earth. Perhaps night lies beyond the window. Jupiter may be somewhere in the sky, or it may be below the horizon and impossible to see at this moment. Whether or not you can see it, the planet continues to turn. Its cloud bands still curl around its body. The Great Red Spot continues to change slowly. Io remains under gravitational strain and continues to erupt. Europa still carries its fractured ice and the question of an ocean below. Ganymede still holds its own magnetic field within Jupiter's greater realm of influence. Callisto still preserves ancient scars across its surface. The auroras continue to glow in wavelengths that do not need to be visible to human eyes in order to be real. And here, the body can rest, the breath can slow. There is no need to travel anywhere in reality. There is no need to remember every detail. It is enough to hold on to one image. Far away in the outer solar system, there is a giant planet without solid ground, yet filled with depth. Without a surface we can touch, yet offering countless signs we can understand. A planet that does not invite human beings to land, but invites us to observe with patience. Perhaps after this journey, the next point of light you see in the night sky will no longer look quite the same. A single point may contain an entire system. A distant object may hold storms larger than Earth. A small moon may contain volcanoes, ice, or a hidden ocean. A dark region that appears empty may be filled with charged particles and force fields. The universe rarely shouts to attract our attention. It simply places small signals before us and waits for us to learn how to read them. Jupiter has receded into the distance, but what it leaves behind is a change in the way we see. Slower, deeper, and less eager to reach conclusions. Not every quiet scene is simple. Not everything that appears small to the eye is small in meaning. And not every place beyond the reach of our feet lies beyond the reach of human understanding. The night remains quiet. Earth continues to support us. And somewhere beyond, the largest planet in the solar system keeps turning through the darkness, holding its moons, its storms, and its invisible magnetic realm. It does not need to know that we are thinking about it. But once we have thought about it a little more deeply, that point of light can never again be only a point of light. It has become a world.